Konsaha College of Arts and Science for Women, Krishnagiri, organizing the national webinar on fuzzy mathematics. Welcome morning with a smile on your face, love in your heart, good thought in your mind, and you will have a wonderful day. Good morning to one and all gathered here. Prayer does not fit us for the greater work. Prayer is the greater work. I now request our team to play a prayer song.
Bless the Lord, oh my soul, oh my soul. Worship His holy name. Sing like never before, oh my soul. Worship Your holy name. The sun comes up, it's a new day dawn. It's time to sing your song again. Whatever may pass and whatever lies before, let me be singing when the evening comes. Bless the Lord, oh my soul, oh my soul. Worship His holy name. Sing like never before. Oh, my soul, worship Your holy name. You're rich in love and You're slow to anger. Your name is great and Your heart is kind. For all Your goodness, I will keep on singing. 10,000 reasons for my heart to find. So bless the Lord, oh my soul, oh my soul. Worship His holy name. Sing like never before. Oh my soul, I worship Your holy name.
The freedom of soul comes when we start reading her holy books with soulful and symbolic understandings.
Reading from Holy Bible. First Peter chapter 2 verse 17 to 18. Honor all men. Love the brotherhood. Fear God. Honor the king. Servants, be subject your master with all fear, not only the good and gentle, but also to the few words. This is the word of God. Thanks to be God.
Reading from Holy Quran. When you're going through something hard and you start wondering where Allah is, just remember the teacher is always quiet during a test.
Bhagavad Gita. Reshape yourself through the power of your will.
Never let yourself be granted by self will. Sunshine is a welcome thing. It brings a lot of brightness. As welcoming ever remains to be a prominent tradition, I take an immense pleasure in inviting Miss J. Mehala, a Department of Mathematics, to welcome the gathering. Welcome you, ma'am.
Time is like a river. You can't touch same water twice because the flow that has passed will never pass again. It gives me great pleasure to extend you all a very warm welcome on behalf of PG Department of Mathematics, organize the national webinar on fuzzy mathematics. Hard work is the most important key to success. Without being willing to hard work and put everything into a venture, success is nearly impossible. Yes, it's true. I take an immense pleasure to welcome our respected Secretary, Reverend Mother C. Noel Rani, FSAG, the sculptor of human character, a seasoned intellectual and a navigator for this flagship of knowledge. She is a great woman, giving the full support to us and all the time to did our work success. Welcome you, Mother. The function of a leader is to produce more leaders, not more followers. Yes, it is none other than our respected principal, Reverend Dr. E. Glitter Sumangali, FSAG. You are our leader. Show motherly love, give fatherly confidence. Your endless care, guidance, and support so that you are a great leader. Welcome, sister. A warm smile is the universal language of kindness. Yes, it is suitable for our college vice principal, Reverend Sister A. John Diana, FSAG, who has been a strong pillar of support to our college. Welcome you, sister. To be inspired is great, but to an inspiration is an honor. Well, it is suitable for our resource person with this true knowledge, Dr. A. Felix, Assistant Professor, Senior, Vellore Institute of Technology, Chennai. A very warm welcome to you, sir. Hard work does not necessarily success, but no success is possible without hard work. Yes, it's true with mind of receiving today's surprise. Let's all open up our mind to our resource person, Dr. Prabjyotka Bajaj, Assistant Professor, Birla Institute of Technology, Mishra, Ranchi. A very warm welcome to you, ma'am. Coming together is a beginning, keeping together is a progress, working together is a success. That is team building. Yes, I extend my warm welcome to the coordinators, members of the organizing committee, and my dear students who have put more efforts and hard work, which play a big role on this day to be a success. Welcome to my dear colleagues and dear students. So powerful is the light of unity that it can illuminate the whole earth. I extend my feelings with a hearty welcome to various college HODs, assistant professors, research scholars, and the students who have united with us to the light of knowledge. Your presence here is highly valuable. Welcome you all. Last but not least, I'm happy to welcome the non-teaching and supporting staff members to make this event a great memorable success. Welcome you all. Once again, it's my glad to welcome each and every one of us. Thank you.
Thank you, ma'am. That if your action inspired others to dream more, learn more, do more, and become more, you are a leader. Now, I invite Reverend Sister Dr. E. Grita Sumangali, FSAG Principal, to deliver a speech. Welcome you, Sister.
Thank you, Kirtana. Respected Reverend Sister A. John Diana, Vice Principal, resource persons of today's national webinar, Dr. A. Felix, Assistant Professor, Senior, Vellore Institute of Technology, Chennai campus at Chennai, Dr. Prajot Kurur Pajaj, Assistant Professor, Birla Institute of Technology, Ranchi, Ms. J. Meghala, Head of the Department of Mathematics and convener of this national level webinar, Ms. M. Jayapriya, Organizing President of the Mathematics Association, staff coordinators, participants from various colleges, research scholars, and my dear students of the Department of Mathematics of our college, pleasant morning to all of you. I am pleased to welcome you all to this webinar. It is with immense glad I appreciate the head of the department, convener, organizing president of the association, and staff for taking unwavering effort to organize a national webinar on fuzzy mathematics. I appreciate the organizing team for their indomitable contribution that you had made for the progress of the department and for the growth of the children. When I was reading on fuzzy mathematics, it was found very interesting and exciting. In real world, there exists much fuzzy knowledge, so to say, the knowledge which is vague, uncertain, inexact. Human thinking and reasoning frequently involve fuzzy information. Human can give satisfactory answer which are probably true. Our system are unable to answer many questions many a times because the system are designed based on classical set theory, which are unreliable and incomplete. We want our system should be able to cope up with unreliable and incomplete information. Fuzzy systems have been provided solution for so many problems that exist. The high visibility of fuzzy logic and mathematics based on frequency logic is primarily due to their high successful application in many areas of human affairs. The current status of these applications are in the various areas of engineering, natural, social and earth sciences, psychology, medicine, management and business decision making, pattern recognition, image analysis, risk analysis, music, among others. In each of these areas, the significance of using fuzzy logic and the associated mathematics is crucial. I'm certain this national webinar would throw light on fuzzy mathematics and inspire the participant to take up research on this area. In this virtual conference room, I recognize you have all fascinated to be connected for further contribution through research. I believe that by participating in this webinar, you are at right place and the right time. Together, let us accelerate the exchange of ideas and scale up of good practices to take up research on fuzzy mathematics. I'm confident that you will find new ideas. I wish you all a very successful webinar. God bless each one of you. May God be with you all. Thank you.
Thank you, sister, for your respectful words. Giving encouragement to others is a most welcome gift. For the result of it are lifted spirits, increased self worth, and a hopeful future. Now, I invite Reverend Sister A. John Diana, FSAG, Vice Principal, to deliver a speech. Welcome you, sister.
Thank you, Kirtana. Mathematics gives us hope that every problem has a solution. Mathematics gives us hope that every problem has a solution. Great morning to Reverend Dr. Yeglita Sumangali, Principal, Resource Person, Dr. A. Felix, Assistant Professor Senior, VIT, Chennai, Dr. Prabha John, Assistant Professor, Birla Institute of Technology, Ranchi. Convener, Ms. Meghala, coordinators, Ms. Jaypriya, Dr. B. Morgan, committee members, G. Aruna, Ms. Rithya, Ms. Francisca, Ms. Sentamil, Ms. Geraldine Irudayameri, and Ms. A. Pumagal, Assistant Professor of Department of Mathematics of Gunsaha College of Arts and Science for Women, and all the all the faculty members from other colleges and research students and my dear beloved students. Happy morning. If mathematics is tough, everything will tough. If mathematics is tough, everything will tough. Those face maths is a problem, they wouldn't find the solution. Those face maths is a problem, they wouldn't find the solution till now. In that sense, you're also smart who solved problem and became the solution giver. You deserve the spirit of curiosity, the sense of discovery. You're so genius, training yourself as a human computer and fastest calculator. The maths teacher could be a great friend who play with the numbers and inculcate interest in the minds of the students. Hope this wonderful session will assist us, all of you, to excel in life as a successful person. Especially this webinar on fuzzy mathematics will open new windows within and explore the joy of learning. Especially this webinar on fuzzy mathematics will open new windows within and explore the joy of learning. I congratulate the resource persons taking all the young students, especially these research students, with a new spirit by instilling great hope that every problem has a solution. I do appreciate the head of the department, coordinators, committee members for organizing national webinars on fuzzy mathematics. Dear students, all the very best. Make yourself really to acquire and pursue from the great people over here. So thank you very much and all the very best. Thank you.
Thank you, sister, for your energetic words. Teaching is the profession that teaches all other professions. I now invite Ms. M. Jayapriya, Assistant Professor of Maths Department and Organizing President, to introduce the resource person. Welcome you, ma'am.
Good morning and a very warm welcome for one and all gathered here. I feel very proud to introduce one of the research persons of this webinar, Dr. A. Felix. Dr. A. Felix, MSc MPhil PhD, is presently working as a Senior Assistant Professor, Department of Mathematics, Vellore Institute of Technology, Chennai. He has got PhD degree from University of Madras. His field of specialization is fuzzy set systems and fuzzy graph theory. He has published 3 papers in Springer and 1 in Taylors and Francis, and also can proudly say he has got many awards for his excellence. He got for the Razin Research Award for the year 2012 by Loyola College, Chennai. He got Young Research Award on Fuzzy Method given by Integrated Intelligent Research IAR, Chennai for the year 2017, and awarded Outstanding Scientist given by VD Good Technology Factory in the 12th International Scientist Awards on Engineering, Science and Medicine on 2020, Visakhapatnam, India. Also, he is acting as sub-editor in the International Journal of Data Mining Techniques and Applications, and as well International Journal of Business Intelligence. I request, dear participants, I request you to give your watching to make use of his purpose of presence to the fullest. Welcome you, sir.
Thank you, ma'am. Now, I hand over the session to Dr. A. Felix. Welcome you, sir.
Is my screen visible, ma'am?
Yes, sir, you're visible, sir.
Yeah. Thank you, ma'am, for your kind words about me. Uh, Warm welcome, pleasant morning to each and every one of you. At the outset, I would like to thank the management of Gonzaga College of Arts and Science for Women, the patrons, secretary of the college, Reverend Mother C. Noel Rani, Reverend Dr. E. Glita Sugamangali, Principal, Reverend Sister John Diana, Vice Principal, the convener of this webinar, Professor J. Meghala, Head of the Department of Mathematics, the coordinators of this event, Professor M. J. Priya, Dr. M. Morgan, and all the committee members of Department of Mathematics of this college for providing this wonderful opportunity to interact with the student fraternities. It always gives joy for me to meet and to interact with the students. Thank you. A few days back, our head of department called me and asked to give a talk on fuzzy sets. I said, who would be the participants? She said that only the undergraduate, some postgraduate student would be participating in it. Therefore, I just made my talk is very simpler on introduction to fuzzy sets and some of its applications. Our principal rightly pointed out that why do we need this fuzzy sets and all. Okay, the objective, the motivation of this webinar, she rightly pointed out. We, the human, has the capability or capacity to express the, the real feelings of the situations, but the machine cannot. How we can make the system to learn how human thinks or how human acts. If we do that, then the system will also act better. Okay, fine. That's what Dr. Principal said. You would have heard this fuzzy sets, fuzzy logic. Okay. Before we begin this talk, I'll just offer this virtual apple to all of you. So have it and taste it. The outline of my presentation would be introduction to fuzzy sets, membership functions of fuzzy sets, the properties of fuzzy sets, the extension version of fuzzy sets, the fuzzy numbers and its arithmetic operations, and some of the applications related to fuzzy sets. Okay. The first thing, before we go into the sets, fuzzy set and all, the mathematics is the philosophy. Okay, philosophy is from from the logic. Okay, everything is coming from the logic. We must be knowing what is the logic. The logic is the declarative sentence. In English, we do have four types of sentences: declarative sentence, imperative, interrogative, and then exclamatory. So logic is the declarative sentence. It declares. Okay, it gives something. The sentence gives something. Okay, logic is a declarative sentence. It is only two values, either true or false, but not both. Okay, a sentence can have truth values, either true or false, but not both. Okay, that is the logic we know. Okay, so for example, if you see this, my set is, I'm defining the set of all people who are attending this webinar. The set is very clear. The set of all people who are attending this webinar. Okay. The set is very clear. And then if you talk in terms of the logic, uh, today is a Sunday. It's a declarative sentence, but the truthness of the statement could be either true or false. The truthness of the statement would be false because today is not Sunday. Okay, it's a logic. Okay, and if you put it this in terms of the set perspective, I said I define my set. The set is, the set is the collection of well-defined distinct object. That is our set. Here I define my set as X, such that X is the people who are attending this webinar. Okay, attending this webinar. The set is very clear. No uncertainty, no ambiguity, nothing is there. Its set is very clear. The people who are attending this webinar will be in the set. Okay, the people who are present in this particular webinar, who will be assigned, the grade is 1. The people who are not presenting this webinar, who will be assigned 0. Okay. In terms of the classical set perspective, we will be defining a set. Okay, now we are very clear what is the logic and what is a set. Okay, now initially I've given a apple to taste. Okay, if I ask the question, is it tasty? Your answer could be either yes or no, isn't it? This is how you can say this. This is a Boolean logic. Two values you will be giving. Once you taste the apple, if the apple is very much tasty, immediately you will express your feelings like, wow, what kind of tasty it is. Where did you buy this apple? Like this, we would be expressing. The human has the capacity to express the real feelings of the tasteness of the apple. Okay, but if the real emotion cannot be expressed in your Boolean logic, in your crisp set. Okay, whereas this something at fuzzy logic, the real feelings, emotion can be expressed. The tasty can be expressed as very much tasty, tasty, moderate tasty, little tasty, very less tasty. Like this, you can classify. But in a statement, look at there. Previously, we have seen the logic. Declarative sentence, it is only two values, either true or false, but not both. Whereas here, we are having the tasteness of the apple or being given so much of value, very tasty, tasty. Okay, this is where the fuzzy logic begins. Okay, so the fuzzy logic is the multi-value logic. It provides the real emotion, real feelings of the situations. Okay, fine. Previously, we had only logic, and some people looked this fuzzy logic in a different perspective. And if you look at the 18th century, Charles Peirce wouldn't believe in the separation between true and false. Okay? He didn't believe only true and false is there. Okay? There is a separation between true and false. Something is there, something in life is a continuum. Something, it is there from true and false. Okay? And even the Russell, the great philosopher, who said, all language is vague and went for the saying, vagueness is a matter of degree. For instance, let me put this logic. Okay.
Sir, sorry to interrupt, sir.
Yes, ma'am.
So the screen is not visible, it seems, sir. Participants are dropping messages in the chat box. Your screen is not visible, it seems.
It is visible only, madam.
Is it visible now?
Yes, visible, sir.
Okay.
But try to enlarge it, sir. Maximize the screen. Yes.
Okay. Is it fine now?
Yes, sir.
Okay. So before the fuzzy logic introduced, so many people who looked at this fuzzy logic. For example, Charles Peirce, who didn't believe in the separation between true and false. He believed the continuum. Everything in life is a continuum. Okay, between true and false, something is there that he was believing in it. And if you look at the Bernard Russell, who also saying, look at the statement given by the Russell. A liar says, I'm a liar. What is the truthness of the statement? A liar says, I'm a liar. What could be the truthness of the statement? If you say this is a liar, he accepts himself as a liar. He could not be a liar, right? He speaks truth. Who is a liar? He never speaks truth. The fellow would be called as a liar. But here, a liar says, I'm a liar. But in this statement, you cannot bring true and false. Okay, something is there in between. That's what the Russell has said. Okay. Another statement. Look at this. Another statement. All of the men in a particular town either shaved by themselves or were shaved by the barber, and the barber only shaved the men who did not shave themselves. Okay. In a certain city, all the men either shaved by themselves or shaved by the barber, and barber only shave the people who are not able to shave themselves. Now answer this question: who shaves the barber? If barber shaves himself, then what is it? He would be in the first condition. What is it? All the men in this town either shaved by themselves or who shaved by the barber. Barber only shaved the men who did not shave themselves. Okay. We could not bring the true value in the statement itself. Something we need to bring. Okay. So, and after them, Lukowitz also said three value. He brought the three value logic between true and false. Possibility he brought the possible. Something is there. Okay. And if you look at in the statement, the between the true and false, something is there. Partial true and partial false would be there. Okay. And Max Bloch and he outlined the precursor of the fuzzy sets. After their argument, Lord Pializza, the year 1965, brought the concepts of the fuzzy logic. Okay. So initially I said, what is it? The set, I said my set, X is the set of people attending this webinar. Okay. Attending webinar. Okay. My set is very clear. If they attend, they'll be given 1. If not, 0. My set is very clear. Now, another set I'm defining. X is the intelligent people, the set of all intelligent people who are attending this webinar. Okay. Now we are getting confused whether who would be in this particular set or not. Intelligent, beautifulness. Okay, these are the terminology are brought some what is it? Uncertainty. Initially, this set is very clear. We don't have any doubt. We are in this particular set. But now, X is the set of all elements, a set of all intelligent people who are attending this webinar. Now, everyone has the question that whether we would be in this particular set or not. Okay. To quench this kind of uncertainty, Zade has introduced the concepts of fuzzy sets. So previously, the grade for the classical set is defined. The grade is, of course, X is the universal set in which A is the subset. The membership grade is defined between either 0 or 1. The set of all elements of A takes the value either 0 or 1. Okay. Whereas in the fuzzy sets, okay, A tilde, and of course here the boundary is very clear. Here the boundary is not very clear. It's not clear. There is a lot of uncertainty, ambiguity. The set of all elements of X takes the value between 0 to 1. Okay. Fine. So this is what the lot P Alizada is defined. Now look at this. X be a non-empty set. A fuzzy set x tilde in X is characterized by a membership function mu of A of X, which mapping from universal set to the closed interval 0, 1. If X completely in your A, then 1. If X does not belongs to A, then it's a 0. If X partially in this particular A, then we are taking the values in between 0 to 1. Okay. The fuzzy set is defined in another ordered pair, set of all ordered pairs. Every pair of every element will be assigned some membership grade. This is called the membership grade. Okay, x comma mu of A of X. Some author denotes this kind of symbol. Okay, fine. Now you would be asking a question to me that how the membership grade is being assigned. How the membership grade is being assigned. For example, let me take the situation. Okay, A is the my set A tilde X such that a real number close to 0. Okay, this is the membership. This is my set. Okay, I want to make this set. How the membership grade is being assigned for this X close to 0. Okay, this is 0. How the close to 0 can be defined. Okay, so what is it? -1 and 1 are close to 0. Even -2, 2 is also close to 0. -3 and 3 are also close to 0. Okay, here how I can define this membership function. How we can define this mu of A of X. How I can define? Let me define. If 0 set completely belongs to this particular set, therefore I can give a membership grade as 1. But this 1 to it gradually decreasing. Similarly, -1, -2, -3 could also be gradually decreasing. For that, I'll be defining my function. Okay, 1 plus x square. You can see this 1 plus x square. Okay, if you substitute 0 here, x is equal to 0, then the membership grade is 1. If you substitute -1, then this will be 1 by 2. You can have the membership grade is 0.5. Okay, this is 0.5. Okay. Similarly, 0.5, you can also membership grade is 0.5. If you substitute -2, if you want to find it out the membership grade as of -2, this will be 4. 1 by 5. 1 by 5 is 0.2. Okay, this is 0.2. Similarly, this is also 0.2. And if you substitute 3 here, 1 by 10, you can have 0.01. Okay, 0.01. Similarly, this is also 0.01. And when it goes like this. It tends, even you can substitute, what is it? X is equal to 1000. What will happen? It never reaches to 0. It goes. You can have this kind of shape. Okay, you can have the bell-shaped curve, the normal distribution curve. Okay, the structure of the fuzzy number is the bell-shaped curve. Okay, bell-shaped curve. Look at there how the function is defined. Okay, this is close to 0. Okay, I want to make it still my fuzzy set as very close to 0. Okay, this is close to 0. Now real number very close to 0. I want to make very close to 0. Now how I can define my set? This is close to 0, very close to 0. How I can define? Still I want to make very close. So I can define this fuzzy set whose membership function is defined as 1 upon 1 plus x square whole square. If I define where x is from -infinity to infinity, here also you can take. Okay, so here if you take 0, of course the membership grade you will be getting 1. And then if you take 1, then you can have 1 You can have 2, 4. So 1 for 1, what is the membership grade we are getting? 1 by 4. Yes, 1 by 4. For 1 by 2, 1 by 4 will be getting. And then similarly for 2, if you substitute 2 here, then we can have 4, 5, 1 by 5 square, 1 by 25. Still, you will be getting very, very closer. Okay, you will be getting very, very, very closer for this membership grade. Okay. The previously, if we have defined a close to 0, this is very close to 0. Still, you can define very, very close to 0. Close to 0 can be defined. Your membership grade is defined as, what is that? You can increase 1 plus x square whole cube, where x from minus infinity to infinity. This will give the membership grade close to 0. This is how we can define the membership grade. Okay. Yes, fine. Yeah. Now you can have after doing this, what we can do, you can ask me the questions after doing. For let me take the first example itself, the close to 0. Okay, from this you can define so much of thing. Support you can define, and then core you can define, alpha cut you can define. Okay, so the one such thing is alpha cut. Let me define. Okay, alpha cut. After doing this fuzzy set, you need to take some decision. I want to take the membership grade close to 0. Okay, I want to make the membership grade close to 0 with some certain grade, a certain grade. So let me define. The alpha cut is defined as, okay, the fuzzy sets with the alpha cut is defined as set of all elements x such that whose membership grade greater than alpha, greater than or equal to alpha. Okay, if it is strictly greater than alpha, that is a strong alpha cut. Okay, fine. So the first membership grade is the first set. Let me take x is minus 3, minus 2, minus 1, 0, 1, 2, 3. And the membership grade is, for 0 is 1, this is 0.5, this is 0.5. And then for this, minus 2 is 0.2, this is also 0.2, this is 0.1. Okay, this is for the first fuzzy sets. We have taken only from minus 3 to 3. Okay, so for example, let me take, this is minus 3 to 3 that I have taken. Here x is from minus 3 to 3 whose corresponding membership grade. Okay, now here I want to make alpha cut. Okay, so here I just make alpha cut is membership grade greater than 2 I want to make. So what are the elements will be there? The membership grade should be, the elements takes the membership grade greater than 0.2, greater than or equal to. So from minus 2 to 2 will come. Minus 2, minus 1, 0, 1, comma 2. Similarly, the membership grade 0.5. The elements whose membership grade more than 0.5 will be taken into an account in this particular set. Minus 1, 0, 1. Okay, this alpha cut plays a very important role in decision making. Even for example, entrance examination is conducted for any kind of seats to enter into university or colleges, and they are keeping some cutoff. Okay, so if the cutoff is 191, what is the meaning of this? The people who score more than 191 and equal to 191 who will be eligible to enter into the particular college, who will be given admission. The same way, after assigning membership grade, okay, the alpha cut plays the major role in taking a decisions. Okay, fine. So you know that alpha cut. Okay, another definition we can learn here is the cardinality. In we have set theory, we have learned the cardinality. What is the cardinality? Cardinality is the number of elements in the sets. Okay, number of elements in the set. How the cardinality can be defined in the fuzzy sets. Okay, usually A is the set, The cardinality is denoted the modulus of A or n of A we'll be using. Okay, the number of elements present in the set. This is cardinality. How the cardinality is defined for the fuzzy sets. Okay, so cardinality for fuzzy sets can be defined in a three perspective. One is scalar cardinality, and then a relative cardinality, and then fuzzy cardinality. Okay, there are three cardinality we'll be learning here. Okay. Scalar cardinality, relative cardinality, and fuzzy cardinality. The scalar cardinality is defined as, for fuzzy set, okay, the cardinality, the scalar cardinality is denoted like this: the sum of all the membership grade of your X, the sum of all the membership grade of your X. Whereas the relative cardinality is denoted as norm symbol. This is equal to the scalar cardinality by the universal set cardinality. And then the fuzzy cardinality is defined as okay, the alpha cut of fuzzy sets, the cardinality of alpha fuzzy sets, comma alpha. Okay, the above example let us take. This is this particular example. So here the set is close to 0. Okay, X is close to 0. Okay, real number close to 0. Okay, real number close to 0. This is the example let us take. Okay, so what is this? The scalar cardinality is the sum of the membership grade of all the elements of your X. Okay, so what is it? Minus 3, whose membership grade is 0.1. This is 0.2. Okay, so 0.1 plus 0.2 plus 0.5 plus 1 plus 0.5 plus 0.2 plus 0.1. If you sum this, you will be getting the scalar cardinality. So what is that? 1, 2, 2.4 and 2.6. Okay. For the above fuzzy set, the scalar cardinality would be 2.6. Okay. What is the relative cardinality? So here we have done the scalar cardinality is 2.6, and then the number of elements in your X is, what is it? 1, 2, 3, 4, 5, 6, 7. Okay. So 2.6 by 7. Okay, 2.6 by 7 will be getting approximately something 0.37. Okay, this is the relative cardinality. You know the scalar cardinality and relative cardinality. Now we will be finding the fuzzy cardinality. Here the alpha cut. Let me define the alpha cut. Okay, we are going to find it out. The 0.5 cardinality of the fuzzy sets. Now look at there. What are the elements takes the membership grade more than 0.5? So look at there here. 1 minus 1, whose membership grade is 0.5, and then 0, whose membership grade is 1, and then 1, whose membership grade is 0.5. Okay, so the number of elements here is, whose membership grade is 0.5 is 3. The cardinality of set 0.5 is 3. For example, another set, let me take the alpha cut is 0.2. What are the elements whose membership grade is 0.2? Minus 2, minus 1, 0, 1, 2. Okay, minus 2, minus 1, 0, 1, 2. How many elements are there in the cardinality of fuzzy sets with a membership grade 0.2 is 1, 2, 3, 4, 5. Okay, this is how you can define the cardinality of the set. Okay, so what are the things we have learned? How the membership grade fuzzy sets you have learned, and then how the membership grade in general perspective, how the membership can be defined for a fuzzy set, and then what is the role of alpha cut we have learned, and the cardinality of the fuzzy sets. Okay, fine. This is what we have learned. Fuzzy set can be represented x comma mu comma a of x, where x belongs to x. So this is the universe discourse, and this is the membership function. Okay, this A is your fuzzy sets. Okay, where the membership takes mapping from x to goes into 0 comma 1. Very good. Now we little bit understand why do we need fuzzy sets. The fuzzy set needs to quench or deals the uncertainty, ambiguity, all such things. Before this fuzzy set introduced, something was utilized. Okay, that is probability. Definitely some question comes to your mind that even fuzzy set also the values are taking between 0 and 1, and probability also between 0 and 1. Then what is the difference between probability and fuzzy sets? Definitely the question comes in our mind. Okay, to answer this, and of course, and before this fuzzy set was brought into the picture, probability theory was used to deal the uncertainty. The probability theory cannot deal all kind of uncertainties. Okay, let us see this. Initially, I've given apple to taste. Okay, here two questions is coming to my mind. One is, what is the guarantee that apple is tasty? Okay. Second one, what is the guarantee that we can get the apple in the market? Okay, these are the two questions is coming to my mind. Okay, the first question, what is the guarantee that the apple is tasty and red color? Another question also I can put it, red color, red, tasty and red color. And second one, what is the evidence that we can get the apple in the market? The first question, second question, you can give the answer depends upon the situation. Whether we can get the market apple in the market, we can get it. Okay, we can, depends upon the situation, you can get it, you can easily tell. The second one, and of course here you will have either you can get or not. Okay, you can get and not get. Okay, you won't get. Okay, these are the two possibilities there. Either you will get, you won't get it for the second question. Only two valid. After giving the probability also, you will get, either you will get or not. Okay, and here look at this question. What is the guarantee that the apple is tasty? The tasty cannot be put it into two ways, tasty, not, no tasty. Okay, you cannot put it into two classification. In between, so much of values are there. In between tasty and no tasty, what is it? Very good tasty, moderate tasty, less tasty, very less tasty, and so much of classification you can put it. Okay. Whereas here in the second question, you can get or you won't get, only two classification. Whereas here, so much of classification. And then color, the color you cannot get exactly red. Okay, red to green. Okay, you can get it the partially red. Okay, and then what is it? Partially red and partially green. Okay, so much of classification. The first question you can deal with your probability theory. Sorry, second question you can deal by the probability theory, whereas this we can deal by the fuzzy set theory. Okay, that's what it is given. Probability deals the frequency of the likelihood that an element in a class, only likelihood an element of the class, whereas your fuzzy sets deals with the membership rate by similarity of an element to a class. This is the major difference between the fuzzy sets and the probability theory. I hope you can understand this examples. Similarly, you can also think some ball. Okay, balls. Suppose in a problem, suppose you are having in an red color, blue color, and then black color balls are there. Okay, you are randomly picked some three balls. Okay, what is the probability that those three balls are red, blue, black? Okay, so you are giving the probability by the probability. But in a black itself, okay, the size I'm putting black, very big, small ball, big ball. Okay, very big, small ball, and big ball. Like this, you are putting a lot of classification. Initially, you had only one classification that can be dealt by your probability theory. Whereas here in the classification itself, you are, what is it? In blue ball itself, you are putting, what is it? Very big ball, small ball, and very small ball. Such a classification is there. What is the guarantee that you will be getting the small blue ball in the blue ball set of all blue balls? Then definitely we cannot deal with your probability theory. Okay, something unique. So that is your fuzzy set will be able to quench it. Okay, fine. Another interesting example is this example. Probably you might have heard from your class. The set of all people, tall people. Okay, so here we will be getting confused. Who is the tall? Suppose we are saying the people who height is more than 5.10, who will be the tall? Now the question comes in our mind. 5.9, is 5.9 height not at all? Okay, and here the 6.3 feet person is there. He is also tall, and 5.10 is also tall. Then what is the difference that we are showing to 6.3 and 5.10? This is the first question. And second question, the 5.9 is very closer to 5.10. Won't E be considered as a tall? Such a question comes in the crisp set. To deal this, we can give the membership grade for the fuzzy sets. If someone's height is 0.2, we can assign 0.9, 6.3 we can assign 1, and more than 6.4 we can assign membership grade 1, and then gradually we can decrease. Okay, even 5.10 we are giving membership grade is 0.5, 5.9 is something 0.4, like this, and less than 3, okay, it is gradually decreasing. This is how we can define the fuzzy set. What is it which deals this kind of uncertainty at this particular point? Okay, fine. As I said, the typical structure of the fuzzy number would be the bell-shaped curve, from where we can define this kind of support. Support is the set of all non-zero degree membership function. Okay, 4 is the set of all the elements having degree is 1. Alpha, ket, height, crossover, normal. The normal is the set of all. Set is the normal if the height should be 1. If the height is 1, then it's a normal. Okay, these are the definition that you will be learning. Okay, another important definition at the fuzzy set is the convexity. Okay, so in analysis we have learned what is the convex set. You take a two elements from a set, okay, x1 and x2, join them by line. The line segment should also completely lie in the set, then it is the convex set. Okay, convex set. For example, you can see this. Take a 2-point line joinment, joining them by the line. This line completely doesn't lie in the set. Therefore, this is not a convex set. You know this. How the convexity is defined for the fuzzy sets is defined by the fuzzy sets. You can see this. Okay, this is one of the fuzzy sets. Here, let me take the membership. Here, take any two elements, x1 and x2. These are the two elements that we have taken, x1 and x2. The membership grade of x1 is this is mu of a of x1. Another membership grade x2 is mu of a of x2. Okay, take any element between x1 and x2. Okay, x1 and x2. We just want to take between these x1 and x2. For that, I'll be using some parameter lambda. Lambda is between 0 to 1. Okay, if if you use lambda times of x1 plus 1 minus lambda of x2, definitely it will lie between x1 and x2. So this is lambda x1 plus 1 minus of lambda x2. Okay, here we are taking in between them. Okay, the membership grade is this we are getting. So this is S, this is mu of A of S. The convexity is defined as, look at there, the membership of any element, anything between x1, x2 should be greater than or equal to minimum of the membership grade of x1 and membership grade of x2. If we take the minimum of these two, this is the minimum. This should be less than this particular. Okay, whereas here what we obtain, mu of s less than mu of x1. Therefore, this is not a convex. Okay, whereas you can think it over this situation. This is some x1 element we have taken. This is the membership grade of x1. This is membership grade of x2. In between, you can take this is the membership grade. Okay, minimum of the membership grade of x1 and x2 should be less than or equal to membership grade of lambda x1 plus 1 minus lambda x2. So here it is equal. Therefore, this is convexity. Okay. Now you understand what is a convex. Okay. Symmetry should be, what is it? Mu of a of x minus c, mu of x plus c should be symmetry. For example, this particular problem we have seen. This is symmetric. Okay. Here mu of x minus 1, mu of x plus 1 whose membership grade is c. Therefore, this is symmetric. Okay, fine. Symmetric about this R. Okay. And these are the open left and open closed. And even this particular example itself we have learned. What is that? Here x tends to infinity. Okay, x tends to minus infinity. This side is x tends to plus infinity. It goes. This side also it converges. It never reaches. It tends. Okay. So this is both side closed. Both side closed. Okay. If one side is open, okay, consider if the membership grade membership grade of 4 less than 4 is 1. Okay, we are assigning 1. Okay, this side is open, whereas this side is closed. So look at there, x tends to minus infinity, mu of x is 1, whereas limit x tends to infinity, mu of x, this side is 0. This is open left and this side is closed. Whereas open right, mu of limit extends to this is plus infinity. Yes, right. Limit plus infinity mu of x is 1. Whereas this is 0. This is open right. Okay. And both side is closed. A limit extends to minus infinity, extends to plus infinity should be 0. Okay. This is open left and open closed. Okay. These are the way we can define. Okay. As I said, in the typical structure of the fuzzy number is the bell-shaped curve. From that, we can derive so many special types of fuzzy number, triangular, trapezoidal, that we can define. So you can see this the special types of fuzzy number. From that, you can define what is it? Triangular you can define, and then the trapezoidal also you can define. Okay, triangularity and trapezoidality can be obtained from the bell shape. Okay. That we shall see. Let me give some situation. Suppose I'm using some digital pad, okay, for doing this presentation. Consider this digital pad cost is would be 500, but exactly you won't get at the 500. Okay, I want to purchase this digital pad. Okay, though it is available in the market for the cost of 500, you cannot get it everywhere for the 500. Okay, and if you go in a what is it? Some particular shop, you may get it at the 550, and somewhere you will be getting 450. Goes on. Okay. So the cost cannot be determined exactly one point. So the uncertainty arises this particular point. Okay, if I get 400, less than 400, I may suspect that the quality is not up to the mark. I know this. The price is worth of 500. Okay, if I'm getting less than 400, then we will be getting suspect on the what is it, this digital board. Okay, because it may be some fault would be there. That's the reason they are giving less than 400. Okay, so 400, if I get less than 400, it would be, I'm not be satisfied. Okay, if I get exactly 500 rupees, I'll be 100% happy. Okay, fine. If the cost prices increases, okay, in terms of the cost, I won't be happy, because when the cost is increases, the my happiness level will also be decreases. Okay, so the uncertainty at this particular point is depicted in terms of the triangular form. Okay, so the slope you can define uncertainty at this particular point. Instead of this, I can make some interval. If I get some 475 to 520, okay, fine. Okay, with the interval I'm making, price 575 to 525. If this interval, then I would be happy, then okay, no issue. So you sometimes you may not be getting exactly in this interval. Sometimes you may be getting 450 and then 550. In the same way, if you are getting less than 400, then you will be suspect on the quality. If more than 600, you won't be happy because the cost is high. Okay, this is uncertainty at the interval. Here the uncertainty at this point. The uncertainty at the interval, you can gradually decrease the membership grade like this. Okay, so if I get the prices from 400, 475, 525, 600 with a 4 tipple. Okay, this is the trapezoidal. The cost is defined in this form. The 500 uncertainty at this 500 is expressed as 400, 500, 600. If I get exactly 500, then 100% will be happy. Less than 600, you won't be happy. 400, less than 400, you won't be happy. Okay. So you will be getting the triangularity, whereas here you will be getting the trapezoid. Okay. These are the two fuzzy number is being predominantly used in all the fuzzy sets for assigning the membership grade of a fuzzy set. Okay, fine. How the membership grade is defined for the triangularity and trapezoidal, we shall see here. Okay, so let us take this. Okay, fine. X is a real line. The membership grade for the triangularity is defined as, okay, like this. If the axis lies between A and B, okay, then it would be x minus a divided by b minus a. This is be obtained by our slope formula. Okay, similarly this is forward difference table. Okay, c minus x by the length b minus c minus b. Okay, if x lies between b and c. Okay, otherwise 0. This can also be defined by the maxima and minima operation as well. So we can also define by the maxima and minima operation. So this is the left spread, this is a right spread. The left spread is defined by x minus a divided by b minus a, and the right spread is c minus x by c minus b. So minimum of this comma, otherwise 0. Okay, and then the maximum will be taken. So that is the another way you can define your triangular membership function. You can ask me here how we can find the alpha ket. Okay, suppose I want to make alpha ket. The membership grade is more than 0.5. Okay, I want to choose the people whose membership grade is more than 0.5. This is alpha ket 0.5. Then who are the members? Then this particular member who would be belonging to this particular set. Okay, so for that, in general, the alpha ket is defined as, so let us take this alpha is equal to this particular element x minus a divided by b minus a. Okay, from here we need to find it out at our x. Alpha times of b minus a plus a is equal to x. Okay, comma, and then this side alpha is equal to c minus x divided by c minus b. This will be alpha times of c minus b, and then bring this term to this side. So you can have this is x. Okay, so put together alpha times of b minus a plus a comma c minus alpha into c minus b, where alpha lies between 0 to 1. Okay, so the alpha ket of a fuzzy set is defined like this. Okay, fine. So as I said, the alpha cut plays the predominant role. Another way you can also define your membership grade is like this. Okay. So let us take A is the midpoint. The membership grade is 1. And this spread, the distance is taken as alpha. This will be A minus alpha. Whereas this is beta, this will be A plus beta. Okay. So using this also, here the spread whose distance is alpha, this is beta. From that also you can define your membership grade. If something, suppose this is your X or T. If T lies between the left spread, okay, A minus alpha and A, we can define the maximum membership grade is 1 minus of, okay, all A minus T divided by alpha, this length. Similarly, the right spread, here 1 minus of T minus alpha by beta otherwise. So for this also, you can define the alpha cut. This another way of defining your membership function. Okay. Similarly, the trapezoidal membership function you can define. Okay. So trapezoidal, when x lies between B and C, the membership grade is 1. X lies between A and B is x minus A divided by B minus A. When x lies between C and D is D minus X, D minus C. Using the maximum minimum also, we can define, and the alpha cut of this particular is defined like this. Okay. Using the spread, you can define the membership function like this. There are plenty of membership functions are available. This is the Gaussian membership function, and then the bell-shaped membership function. This is the sigmoidal membership function. This sigmoidal membership function is very well used at the artificial neural network. Okay, so when somebody you're listening, how you recognize that someone is giving the lecture on fuzzy sets. So what is it you hear, and then the message is being carried out to your mind through your neurons. Okay, the signals is being carried out. The weightage, the signals are being carried out by some functions. The function is can be expressed as the sigmoidal function or signal function. This function is very well used at the artificial neural network. Okay, fine. So nowadays the trend is artificial intelligence, where the neural network concepts are very well used, in which the fuzzy logic, when it is incorporated, so the system will mimic how the human thinking. Okay, the system mimics the human way of thinking. Okay, so where the sigmoidal function is being very well used. Initially, your principal said that human has the ability to express uh, or assign a value to some feelings and emotions, whereas the machine cannot. In the machine, if we design or incorporate the fuzzy sets, fuzzy logic in the system, and it acts as how the human acts. Okay, so the various types of membership functions are available. The people are working on the extended version of fuzzy numbers. So you can also look it into the any one of the fuzzy numbers. Okay, so far we have learned the fuzzy sets, and then alpha cut, cardinality of a fuzzy sets, and then how the membership function is defined, that we have learned. Okay, now some standard operations on fuzzy sets. Okay, inclusion. A contain B. How it is defined for a fuzzy set? If the membership grade of A should be less than the membership grade of less than B, then A include B. And when two fuzzy sets are equal, if the membership grade of fuzzy sets A of all the elements equal to the membership grade of the all the elements of your fuzzy sets B, and then the complement is defined by 1 minus the fuzzy sets. Okay, okay. So in logic also, we have connectiveness and an or. Okay, these are the two connectiveness that we have. And discrete mathematics perspective, if we talk this and or, is disjunctive and conjunctive. Okay, and English we are using and or. In set perspective, we are using intersection and union. Okay, these and or, how it is defined at the fuzzy set that we shall learn. Okay, so look at this. A and B are two fuzzy sets. Okay, A and B are two fuzzy sets. How A and B is defined? Okay, so this is your A and this is your B. Okay, this is your the minimum part of this A and B. This is your A and B. So this, okay, mu of A and B is expressed as T of mu of Ax and mu of B of x. Okay, T norm. Okay, the triangular norm. Okay, so because so many people are given some perspective on this and operation. Okay, that we shall see. That should hold. These are the conditions. Okay, so T is mapping from binary operation. Okay, 0 comma 1 to 0 comma 1, or okay, to 0 comma 1. Okay, so that holds commutativity, associativity, and then monotonicity, and then neutral element. Okay, if holds this, then this will be your AND operation. Okay, so look at Zade has defined the mu of A and B of X is defined as minimum of the membership grade of A and membership grade of B. This is Zade is defined for the product mu of A intersection B of X is mu of A of X into mu of B of X for the product operation. Okay. So let us see the examples. A and B are two fuzzy sets. A and B are two fuzzy sets. Here, A complement would be 1 minus of the fuzzy sets. Okay, this will be x1 is 0.9, this is 0.8, 0.6, x4 is 0.5, x5 is 1 minus 0.6, 0.4. Okay, now here we need to find it out A and B by using the Zade operation, minimum of these two fuzzy sets. Now look at there. For x1, the minimum 0.1, 0.1, 0.1, here 0.2, 0.4, 0.3. So minimum is 0.3, here 0.5, 0.4 is the minimum, here 0.6. Okay, by doing the product operation. Okay, so what is this? You'll be multiplying these two. 0.1 into 0.1 is 0.01, 0.2 into 0.2 is 0.04. Like this we can define. Okay, like this you can define in many ways. Okay, how the truth table can be defined for Boolean, and the truth table is defined as if both A and B are true, then A and B is true, otherwise 0. This is how the AND operation for defined for truth tables. Okay, A and B are two statements. The A and B is defined like this. Okay, if A and B are true, then A and B are true. Okay, so let us take A and B are two fuzzy sets, or A and B are two statements whose truthness of the statement is 0, 0.25, 0.5, 0.751. Similarly, A is 0, 0.25, 0.5, 0.751. Okay. Now let us see what would be the AND operation of this statement A whose membership grade is 0.5 and B whose membership grade is 2.5. So what is that? Here it is taken the minimum of these two. So what is it? 0.25. Okay. This is the AND operation. Okay. Fine. Similarly, so many people who have given their perspective on this AND operation. AND is nothing but the conjunction. Okay, conjunction. In discrete mathematics we have learned conjunction. Okay, so here Lukovitz defined the maximum of the membership grade of X plus membership grade of B minus 1 comma 0. The Lukovitz conjunction, the immature conjunction of any two fuzzy sets C and B is defined like this. Like there's so many people who have given their perspective on it. Okay, and then all of
என்னடா கொடுக்கணும் எஸ் கொடுக்கணுமா
Tamil, would you put yourself in a mute? Okay. And then OR operation, fuzzy OR operation is defined. Okay. For OR, so this is your union, and this for a discrete perspective, disjunctive OR. Okay. And then this is maximum. Okay. So A and B are two fuzzy sets in which what is the maximum portion? This is the maximum. OR operation is defined.
வெளில ஊத்தாது
This is T codon.
ஆமாண்டா தலைவன் மனோவை விஷ்ணுவை பார்க்காம இருக்க முடியல, அதனால வெளியே
இங்க என்ன கிளிக் ஆன் எஸ்ஸா?
நான் நோ கொடுத்துட்டேன். அந்த வாட்ஸ்அப் லிங்க் அனுப்பிச்சுடுறேன் எனக்கு. ஆமா ஆமா.
Yes, participant, please make yourself mute. You're disturbing others. Is it viewable? Are you able to see this? Participants, can I get your response?
Yes, sir.
Yes, sir.
Okay. So this is the triangular conorm, and of course that is also defined from the closed interval 0, 1 square to 0, 1 square. It holds the commutativity, associativity, monotonicity, and the neutral element. Okay. So for Zade perspective, the maximum of the fuzzy sets. Okay. So mu of A union B of X is defined as maximum of mu of A of X and maximum membership grade of fuzzy sets B. For a product, mu of X plus mu of B of X minus mu of A into B. So this is nothing but what we learn at statistics, the inclusion-exclusion principle. The probability of two events. Okay. Sum of the probability of two events. Okay. This is Zade's R and this product operation. So let's see for these two. A and B are two fuzzy sets. So A union B, the maximum will be taken. And then A plus B. Mu of A of X1 plus mu of B of X1 minus mu of A into B of X1. We can define the truth table for fuzzy sets for R operation. So let us consider the statement B, whose membership grade is 0.5, and the statement A, whose membership grade is 0.5. So what would be the R operation of these two statements? Okay. The maximum of this, okay, maximum will be taken. Similarly, the disjunction operation is defined for Lukowicz, Schumacher, Einstein. So that you can think it over, take the same example and try it for the Lukowicz and Schumacher and Einstein. Okay. So far we have discussed the properties of fuzzy sets, operations on fuzzy sets. Okay. Now the question is, the fuzzy set satisfy all the operation of the crisp set. Okay. That is the question. The answer is the fuzzy set deals all the properties of crisp sets except the two properties, law of excluded middle and then law of contradiction. These are the two operations do not hold good at the fuzzy sets. Who are they? Okay. Law of exclusion middle. So we know this at the crisp set. A is your fuzzy set, and then the complement of the fuzzy set. So look at this. This is your X. A is your set. A complement. This is your A complement, right? If you take A union A complement is X at your crisp set. Whereas at the fuzzy sets, A union A complement won't give the fuzzy sets. Look at there. Suppose A of X. This is your fuzzy sets. The complement would be X1 is 0.9. This is 0.7. X3 is 1 minus of 0.4, 0.6. X4 is 0.5. If we take the union of these two, union is maximum will be taking 0.9, yes, 0.7, 0.6, 0.5. This do not give the entire universe set. A union A complement doesn't hold good at the fuzzy sets. That is a law of exclusion. Okay. Another one is law of contradiction. So at the fuzzy sets, the same set, X is a universal discourse, A is your set. Okay. And this is your A complement. A intersection A complement is empty set. Okay. No element is common between A and A complement. Whereas at the fuzzy set, A intersection A complement is not empty, is a non-empty. So for example, A of X, this is your A of X. Okay. A complement is X1 is 1 minus 1, 0, X2 is 0.7, X3 is 0.6, X4 is 0.5. If you take A intersection A complement, for this is defined as minimum, right? So X1 is minimum 0, this is 0.3, this is 0.4 and 0.5. So what is the law of excluded, law of contradiction? It says this is equal to empty, but at fuzzy sets we arrived at non-empty. Therefore, the law of contradiction and law of excluded middle are not good at the fuzzy sets. Okay, fine. These are the two things that we need to remember. Okay. Suppose A is your fuzzy set, you want to identify how far the set is fuzziness. So to determine that, entropy concepts can be used. Okay, entropy is 1 minus 1 by n, sum of membership of the set xi and log of mu of xi plus 1 minus of mu of xi into log of 1 minus mu of xi. Using this entropy formula, you can identify how far the fuzzy set is involved fuzziness. Okay. So this is the fuzzy set you can take. By doing this, you can identify the fuzziness of fuzzy set is 0.2499. Okay. Similarly, you can define the measure of inaccuracy fuzzy sets. Okay, fine. So now let us move on to uh, the applications of the fuzzy sets. So in the application, a lot of applications are there. Even in the principal inaugural address, she was pointing out the application where it is being medicine, engineering, data science, and all the field the fuzzy sets is being used. Okay, so data classification, decision analysis, expert system, time series prediction, robotics, pattern recognition, everywhere it is being used. Okay, the beauty of fuzzy sets is there in the application. Okay, most of the Japanese people are very well used, and if you look at the your washing machine, the fan, uh, an air conditioner, air cooler, everywhere the fuzzy set is used. Initially, when you switch on the fan will be functioning, and when you switch off, the fan won't be functioning. Only two on and off conditions are there. But if you want to slow down, if you want to make it fast, we cannot do those days. Now and then they made a regulator with a 5-point scale, 1, 2, 3, 4, 5, and then they have made it as the continuous smoothness. Okay, okay. And then if you look at the washing machine, those days, if you put one cloth or so many cloths, it consumes the same amount of time. But now you look at the term fuzzy logic, such option is there. It takes the time according to the cloth quantity and the what kind of cloth, jeans or sari, and based on it, it takes the time. Okay. You as I said, the Japanese people who are used this fuzzy logic very well. And if you look at this railway train, 1000 N series train in Japan, this is being operated by the fuzzy logic. Okay. So with the fuzzy logic mechanism, the train is being operated, and of course, it acts 10% more efficient than the human controlled acceleration. Okay. And of course, though it gives a lot of application, in meanwhile a lot of criticism were also there on fuzzy sets. Okay, so one such criticism that what does one do when there is uncertainty about the value of the membership function. Okay, for example, here I said, here in India 5.5 is not considered at all. Okay, we are giving the membership grade 5.5 is not considered at all. It could be a you could be given a membership grade as 0.3. Suppose a person in China or Japan with a height of 5.5 is considered at all there, but in India it is not. And if you look at West Indies or African countries, 5.5 may not be, it's not considered at all, where all the people more than 6 feet. Okay, it varies place to place. Okay, so here the uncertainty arises in the membership function itself. For that, what we can do? Okay, so for that there are various concepts. The extended version of fuzzy sets are brought into the picture. And of course, Zade has given the answer for when the uncertainty arises in the membership function. Okay, he gave the answer, that is the type 2. We can extend it into the M type fuzzy number as well. Now the people are working on the various types of the fuzzy numbers. Intervalued type 2 fuzzy sets, intervalued, intuitionistic. So many fuzzy sets are being brought into the picture and people are working on it. As I said, This is the membership grade when there is uncertainty in the membership function itself. Okay, as I said, the 5.5 is not considered as a tall year, but some other country, some other region, it is considered as a tall. Therefore, the uncertainty there in the membership function itself. Okay, therefore, in the membership itself, we are going to assign another membership function. Okay, this is the primary membership function. For that, we are going to assign one more membership, that is a secondary membership function. Here, this is taken a domain, okay, and the membership grade is taken as a core domain. People are working on type 2 fuzzy sets as well. Okay, so you can see this is the type 1 fuzzy set. When there is uncertainty, you can see this. For that, we are assigning a membership grade. Okay, so okay, consider this is your domain. Okay, this is your x, and this is your mu of p of x. We are assigning a membership grade. Okay, some particular sets you are assigning where there is uncertainty in the membership function itself. So for that, we are defined one more, okay, set. So this is your domain. Okay, so here we will be assigning lower membership function and upper membership function of this particular element here. Okay, so people are working on the type 2 fuzzy sets. Another one is the intuitionist fuzzy sets. The fuzzy set deals only the how far elements belong to the fuzzy sets, how far elements belong to the fuzzy sets, that your fuzzy set deals. Whereas your intuitionist fuzzy set deals membership, non-membership, as well as the hesitancy part. Okay, so for every element, we can find it out the membership, non-membership. That the hesitancy, the sum of membership and non-membership lies between 0 to 1, and the hesitancy would be 1 minus of mu of minus gamma. Okay, this is the intuitionistic. Okay, here the condition that what is the sum of membership non-membership lies between 0 to 1. Another one, if sum of membership non-membership greater than 1, such a situation comes if you square them. Okay, sum of the square of membership non-membership less than or equal to 1, that is the second type of intuitionistic fuzzy number. So let me give a situation. Okay, this is your membership grade, this is the non-membership grade. If this is mu plus gamma less than or equal to 1, okay, suppose another situation, mu square plus gamma square less than or equal to 1, where sum of membership non-membership greater than or equal to 1. Okay, this is the second type of intuitionistic fuzzy sets. Another situation, if you are taking mu cube plus gamma cube less than or equal to 1, this is the Fermadian membership intuitionistic fuzzy sets. And then they are also using on mu cube plus gamma cube less than or equal to 1. This is Q rank orthopair fuzzy sets. Okay, only under the situation they are being utilized, they are being extending into some other versions. Okay, fine. And as I said, the Pythagorean mu square plus gamma square less than or equal to 1, that is the Pythagorean fuzzy sets. The hesitance is defined as square root of 1 minus sum of the square of the membership and non-membership. If you sum it up, sum of the square of the membership, non-membership, hesitancy would be 1. Okay, fine. Yeah. Yes. Now, initially we have defined the fuzzy number, triangular and trapezoidal. What are the conditions that triangular and trapezoidal should satisfy so that it could be a fuzzy number? Okay, the fuzzy number is defined on the real line. Okay, let A be the fuzzy set that is defined as on the real line. Fuzzy set is the subset of the real line. Okay, in the real line is said to be the fuzzy number if it satisfies the following conditions. Okay, it should be a convexity and should be a normal and then piecewise continuous. Okay, so convex we know that normal, the membership grade, maximum membership grade should be 1 and then piecewise continuous. So you consider this is a triangularity. The function is increasing from the interval a to b and then decreasing from b to c. So the function is being splitted into a to b. Initially it is defined from a to c. Now a to c is divided into a to b and b to c. We have to split it into the subinterval. In the subinterval also still it is continuous. Therefore it is a piecewise continuous. Yeah. And we have learned the fuzzy number, and this arithmetic operation plays a very important role. Okay, there are so many ways you can define your arithmetic operation. So let us consider a and b are two triangular fuzzy number. The addition, subtraction, multiplication, division is defined like this. Okay. The addition is defined as same way of how we are defining the vector addition. Okay. And subtraction is a1 minus b3, a2 minus b2, a3 minus b1. Okay, this is b. Similarly, division. Okay, so from here we observe that the addition and subtraction between fuzzy number provides the triangularity at trapezoidal, whereas the multiplication division inverse need not be the same structures of the fuzzy number. The maximum minimum of fuzzy number is not always in the form of triangular fuzzy number, but sometimes it gives the shape of whatever the fuzzy numbers of a and b are taken. Okay, so to deal this, the weakest t norm also you can define weakest t norm. By using this, we can define the addition, subtraction, multiplication, division that you can define. So what we can do with the fuzzy numbers? Okay, so with the fuzzy number we can reason the thing. Okay, we can reason. Okay, the fuzzy logic means reasoning with the fuzzy numbers. Okay, for example, in everyday we are using, if we wake up early, then we can attend the class on time. Okay, such rules we are making. Suppose in a, as I said, in the train, okay, the 1000 N series train, the fuzzy logic is being operated there, is being used. Okay, the same way, if train goes fast, then slow down. Okay, if the car goes too fast, then slow down. Here, fast, slow is can be the linguistic term that can be assigned the values by your fuzzy numbers. Okay, for example, you can see no influence, very low influence, low, high, very high influence. This can be assigned the values by your the fuzzy numbers. Okay, using this we can, what is it? We can uh, assign a values to the uncertain situations. Okay, so the final, I think 5 to 10 minutes I can spend here. Okay, and always we are in the situation, we are in the sometimes when you want to take a decision, you have a lot of alternatives, lot of choices. At the situation, how we can take a decision, meaningful decision. Okay, everyone we come across with the situation. Those days you had only one choice, only one alternative you can choose. But choosing a college also, you have a plenty of option is there. What college you need to choose? Okay, such uncertainties arises. Okay, we need to take some effective decisions. How we can do that? Okay. Okay, this is the thing we will be doing. This is the 7th step we will be doing. First, we need to identify the decisions, alternatives, what are the colleges you are going to apply, and you are going to gather information about the college and identify the what are the courses are being available, and you are going to give the weightage of the all the courses depends upon the faculties and when the course is being introduced, and then the placement, everything will be taking, and then finally you will be analyzing and taking a decision. Okay, this is the 7 steps. Even the same situation, the same thing you can also make a model as the multi-criteria decision making. Okay, multi-criteria decision making can be put it into two perspectives. One is the multi-objective, another one is the multi-attribute decision making. The first one is, this is the continuous case. All your linear programming problem comes under the continuous case, that is the multi-object decision making. And second one is multi-attribute decision making. Here the plenty of decision making models are available. Here I'll be giving only one model to discuss. Okay. In the multi-criteria decision making, these are the 5 components are very important. The first thing is, what is your goal? Okay, what you're going to do. The second one is definitely, suppose you want to purchase a mobile phone or you want to join any college, you will get some experts' opinion. You will ask some seniors who have already completed the course in a particular college. You will ask their opinion. Okay, or you want to purchase any mobile phone, you will ask the person who are experienced or who are well versed in that particular. Okay, and then you will take a alternatives. What are the choices is there? Even in the particular college, Gonzaga College also, what are the courses are available? Okay, BSc Mathematics, Physics, Chemistry, English. So much of alternatives you are there are there. So what you're going to choose? Okay, and then the criteria, interest. Okay, and then interest in the sense, even if you take BSc Mathematics, in which the faculty you'll be taking, faculty, strength of the faculty, and then campus placement, infrastructures, all the criteria you'll be taking. For mobile phone concern, the alternative is there. What are the phones? Samsung, Nokia, these are the alternatives. The criteria is camera quality and storage of the battery storage and the RAM process, and then cost. These are the perspective you'll be thinking. And then finally, the consequences, you'll be taking the relation and then you'll take a decision. This is what you're going to do that. Okay. So this is the decision matrix. As I said, the alternatives, the mobile phones are the alternatives. The criteria are cost, storage, camera is the criteria, and the relation between them is assigned the values. Fine. Here, one of the simplest model is taken, the Vigar technique. Using this, we are going to learn how the best or better mobile phone can be chosen. Okay. The first one, you need to choose your alternatives and criteria, and then the relation between them, you need to put it. And then the criteria is assigned some weightages. Okay. And then you will be making this decision matrix. Positive, negative, ideal solution will be taking, and then this index S and R Q will be taken. From this, you will defacify and you will be ranking this. Okay. So here, as I said, the linguistic terms are assigned the values. Okay, the poor, medium poor. Okay, so the fuzzy number plays an important role in assigning a values to the linguistic terms. Fine. Okay, so for this particular problem, Apple, Samsung, Nokia, these are the three mobiles are taken. This is our alternatives, and the criteria are cost, memory, camera, battery life, screen size, weights are our criteria. Okay, based upon the expert's opinion, we will be giving the linguistic terms for each attributes and the criteria. Okay, and the criteria are also assigned with some weightage, and then this is your weighted matrix. Decision matrix, and the weights of the criteria. The positive best value and the worst value are chosen. The index SRQ is defined. And finally, we obtained this value. Based on this, the lowest value will be given a ranking 1. Okay. So here, look at this. A1 is got a lowest value, and then A3 has got a lowest value, and then A2, this is rank 3. We have assigned a rank. Okay, so from this, what we observe, the A1 Apple has got the ranking 1. Therefore, among this alternatives, Apple acts the better choice. Okay, so in all the decision making problem, your fuzzy concepts are very well used. In this, the arithmetic operation, the weakest t norm arithmetic operation is being used. Okay, and using this weakest t Vicar method, you can observe, you can make a ranking. From this, you can bring the better choice on the mobile phone. Okay, there are a lot of applications there, so that I'll leave it to you, because due to time constraint, another lecture is going to happen. So with that, I'll stop. There are plenty of areas where you can work on the multi-criteria decision making, on intuitionistic, neurosophic picture, spherical, type of sets, and then you can look at the various arithmetic operation and defalsification method as well. And thank you. With this, I'll stop. If any questions is there, I'm ready to answer. Thank you.
Sir, good morning. It's a very nice presentation. Thank you for organizing, sir, and a resource person. I have only one question, sir. It's well known to you.
Yes, sir.
Uh,
Yes, sir.
can I explain the pentagonal person number and its membership? Uh, I a little bit doubt here. So will
Yes,
you
sir.
please?
Yes, sir. Yeah, yes, sir. I can. So, SAR is asking the pentagonal fuzzy numbers. So, penta in the sense, so we can put it in. This is order 5 tuples: x2, x3, x4, and x5. Okay. So, I'll be putting x1, x2, x3, x4, and x5. Okay. This is your x. This is mu of a of x. Okay. If x3, you will be assigning 1. The membership grade is 1. For x2, maybe let us take some m. x2, this is your x2. x4 also m. This is your x5. Okay, my diagram is not neat. You can think it. For x2, we have assigned x2 and x4. We have assigned membership grade is 1. Less than x1, greater than x5 is 0. So the membership grade is defined as mu of v of x. If x1, x lies between x1 to x2. Okay, how this could be defined? Yeah, x minus x1 by x2 minus x1 times of your m. Because if we take x2, then what will happen? x2 minus x1, it become a 1. So it goes there. Actually, the maximum membership grade of x2 is m. Therefore, we will be multiplying here. M times of x minus x1 by x2 minus x1. Suppose x2 lies between x2 and x3. How this can be defined? The maximum membership grade is 1. Okay. Minus m times of x minus x2 by x3 minus x3. Sorry, x3 minus x2. If you take some x3, what will happen? This will be 0. The membership grade is 1. If you take something in between, okay, you can substitute there m times of this. Yeah, something. If you subtract this, you'll be getting. Have you got it, sir? Sir, are you there?
Yes, 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 sir.
Yes, sir.
Yes, I got it, sir.
Yes, sir. Similarly, you can define, I think.
Okay. Alpha cut, sir. It's alpha cut. Alpha.
Yeah, the same thing. We'll be taking this.
Okay.
If this is your alpha, wherever it touches, you'll be taking this is equal to alpha, and then
Okay.
you'll be giving in terms of x. So here
Okay.
you'll be defining alpha cut of x is defined as if x is lies between x1 and x2, all the cases you will be checking.
Okay.
1. Similarly, if x is lies between, sorry, alpha is, x is lies between x2, x3, and
Okay.
then x3 to x4, and then 4 things you will be getting for alpha.
Okay.
Depends upon the number of spreads.
Okay.
Okay. Thank you.
Okay.
Thank you, sir.
Thank you.
Any other?
Thank you, sir. In previous, we are not familiar with fuzzy, sir, but now it's easy for us. Thank you for your explanation, sir.
Thank you. Thank you.
Now the questionnaire section starts. Whomever want to ask, just ask the questions.
Good morning, sir. I'm Shailaja. My question is, what are the advantages of fuzzy logic, sir?
There are plenty of logic, Shailaja. Uh, for example, initially I said a question, uh, set of all intelligent people who are attending this lecture. Could you answer for it? Who are all the people attending this? So a set A is the set of all girls who are attending this lecture. The set is very clear. Am I right or not? Shailaja?
Yes, sir.
Okay, the set is clear. Another set is set of all intelligent people who are attending this. Will you be able to say this?
We
Cannot.
cannot say it.
So here, some uncertainty, some ambiguity is there. Okay, this kind of uncertainty. Initially, I said only two option is there. When you switch on the fan, it will be functioning on and off. Two state were there, yes or no, by Boolean logic. But between on and off, you can have a lot of option in the regulator. You can have it low level, medium, high, very high, isn't it? This human can feel it, isn't it? Human can feel it. So it is too much of art. I cannot go out. Human can feel it, but the machine cannot do. Okay, you're coming from the too much of art. So what immediately you would ask? Can you speed up the fan? Human can do that, but the system cannot. You're trying to make the system also how the human thinks. So now we have a regulator with a low from what is it, on to off. There are so many options: medium, low level, medium, high, very high, so much of things. Okay, so like this, we have a lot of advantages and applications is there. Good.
Thank you, sir. Good morning, sir. I am Ramya. My question is, however the fuzzy set is useful in medical field, sir?
There are plenty of ways. Okay, even in doctor is not diagnosing the disease immediately. Okay, so in your experience, who would be the best doctor? Who posed the question?
Ramya, sir. Heart specialist?
Yes, Ramya. Who is the best doctor? Whenever you are not feeling well, you are going and meeting a doctor, right? So in
Yes,
your
sir.
experience, who is the best doctor?
Mother, sir.
No, no. Mother is of course. There are plenty of doctor you meet, medical practitioners. Why you are saying mother is the best doctor? Actually, the good doctor will
He is
make
taking care of our family, sir.
the good doctor will always make the patient to talk. What, Ramya? Tell me what is the problem. Then Ramya will spell out all the problem, and then from whatever you spell out, doctor will diagnose this particular problem you may have. Doctor will give some medicine, ask you to take for 2 days. If it is not cured, he will ask you to meet again. This is one type of doctor. Another doctor is there. Without asking you to talk, he will ask, what is the problem? Do you have a headache? Do you have a fever? He will ask the question. Our response would be either yes or no. So sometimes if we say yes to all his questions, then what we feel, if we say yes, then doctor will give a good medicine. At the situation, you may not have a headache. You had a headache at your home. And if you ask, do you have a headache? He may, yes, sir, I have a headache. Okay. So the doctor asks the question, who cannot be the good doctor? The doctor should make the patient to talk. Okay. So even the diagnosis, we cannot take it's not a easy task. Okay, there are a lot of uncertainties there. Even for any particular disease, there are a lot of common symptoms out there. Okay, so we cannot diagnose this disease. A lot of uncertainties there. So the initially doctor would do, he will give a medicine, and still if it is not acute, you will go for the another level. He will go for the medical checkups, blood tests, and so many samples. From that, he will diagnose. From that test also, doctor cannot exactly find it out what kind of disease you are suffering. Okay. So in medical field, lot of applications there. So you can go and search and learn it. Fine. Good.
Thank you, sir.
Thank you. Yes, if no question is there, with that, let me wind up. I'll thank the management of this particular college for providing this wonderful opportunity to interact with the students fraternities. At the outset, I also thank the head of the department, Professor Magala, the coordinators of this event, Professor Jaypriya and Dr. B. Morgan, and all the committee members of Department of Mathematics uh, for this wonderful opportunity. Thank you so much. Thank you, students, for your patient listening.
Sir, thank you so much, sir, for your wonderful presentation. Thank you so much, sir.
Thank you, ma'am.
Thank you, sir. The best teachers are those who show where to look but don't tell you what to see. I now invite Ms. S. Jwalali Nirudaya Assistant Professor of Maths Department, to introduce the resource person. Welcome you, ma'am.
Thanking you for giving me opportunity to introduce our special guest, Dr. Prabodh Kaur Bajaj. Today is the wonderful day. We have our guest here. Today we are pleased to welcome a very special guest, Dr. Prabodh Kaur Bajaj. Dr. Prabodh Kaur Bajaj is presently working as an assistant professor, Department of Mathematics, Birla Institute of Technology, Mesra, Ranchi. She has more than 19 years of research experience in various courses, besides guiding candidates for MPhil and PhD degree. She has got PhD degree from Birla Institute of Technology, Mesra, Ranchi. An interesting thesis title is Fuzzy Approach to Multi-Criteria Decision-Making Problems. She guiding 3 PhD students and project guided 30 students for masters and integrated MSc students. She published 32 research papers in the journals of international repute. She attended 24 more national and international conferences and other seminars and workshops. She talks in many workshops and seminars, and she wrote a book, A Fuzzy Approach to Vendor Selection Problem, and some chapters in other 7 books. She got 4 awards and honors. She is Board of Governors of BIT Mesra, May 2014 to May 2015. Then, Outstanding Women in Science for their contribution and achievement in the field of mathematics by Venus International Foundation, Chennai, March 4, 2017. And Board of Studies, RKDF University, 2021 to 2022. Then Governing Body, Kisliya Vidya Mandir, 2021 to at present. I ask you all full attention to this useful session. I welcome you, ma'am.
Thank you, ma'am. I'll just share my presentation. Yeah, hope you are able to see my screen.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
A very good morning to Reverend Mother C. Noel Rani, Principal, Reverend Dr. E. Jilita Suman Gali, VP, Reverend Senior A. John Diana, Convener and HOD Mathematics, Ms. J. Meghala, Organizing President M. Jaypriya, Coordinators, my dear students, research scholar, and faculty members, first of all, I would like to express my gratitude for giving me this opportunity by PG Department of Mathematics, Gonzaga College of Arts and Science for Women. My topic today is fuzzy optimization. We are aware of the term optimization. So by optimization, we mean we maximize the profit, minimize cost, subject to the constraints. So constraints are nothing but your limitations of resources, manpower, material, or funds. So this is the concept right now that all of us have. Now coming to my talk on fuzzy optimization. So when I talk about fuzzy optimization, it is nothing but impreciseness in objective function. So impreciseness would mean more profit. Again, constraints, impreciseness would be less resources, and in money, limited amount of money that we are using. So this is the concept of fuzzy optimization. Before that, I would just like to give a glimpse of my college. I'm from Birla Institute of Technology, Mesra, Ranchi, Jharkhand. So this is a brief history of my college. With the NAC and NB accreditation, we have part of India like Patna, Noida, Devghar, and Jaipur. Now, coming to my area of research, my basic area is thrust area, I can say, is operation research decision sciences. I'm working in multi criteria decision making under intuitionistic fuzzy environment. Supply chain management, vendor selection problem is my forte. Inventory management also, I worked with a student on a thesis. And finally, fuzzy and intuitionistic optimization, which I'm working on. So I would like to share some of my recent publications. So all these publications you will be able to find in ResearchGate, Google Scholar. This is my papers in Google Scholars, around 40 papers that are there. Some papers are not included. So it will be more than 40 papers, I can say. Yeah, I would like to start my topic of fuzzy optimization by giving a tribute to Zade, father of fuzzy logic, mentioning one of his famous quotes: as the complexity of a system increases, our ability to make precise and yet significant statement about its behavior diminishes until a threshold is reached beyond which precision and significance become almost mutually exclusive characteristics. So the outline of my talk is I'm just going to introduce the topic, how it comes into being. Fuzzy optimization, more I'll be talking about fuzzy mathematical programming problems, its classification, application, and some references which you can use for your future if you're interested in working in this area of research. At the turn of the century, reducing complex real-world system into precise mathematical model was a main trend in science and problems and became one of the most important fields in science and engineering. But all the real-world problems, they are not deterministic. There's nothing preciseness in it. So precise mathematical models are not enough to tackle all practical problems. Now, to deal with imprecision, concept of probability theory came in. Probability theory was criticized, especially in artificial intelligence where it could not be used. Then came the chaos theory to handle non-linear dynamic systems in physics and mathematics. And then came our fuzzy set theory developed by L.A. Zade in 1965. Now, fuzzy set theory is applied in the field of operation research, management science, artificial intelligence, and many other fields. So that is the advantage of fuzzy set theory. Its application area is increasing day by day, and more application areas are coming in. So basically, the concept of fuzzy set theory, as Sir had explained, he has given the definition and the concept. It is a graded concept, but it is not a theory of chance. So now, like mathematical slang, or we can say linguistic variables, as was mentioned by Sir in some of the examples. So these confusing mathematical slangs, difficult functions. So how you have to, they can be best communicated with outsiders by using fuzzy set theory there. Now this concept is very much applied in the operation research. Now techniques like linear, non-linear programming, dynamic programming, and several other application areas in optimization. Now, before this, I have some questions for you. Like, I think I would like the students to answer these. Fuzziness in daily life. If I ask, how is the weather today in Tamil Nadu? So what will be your answer? Yeah, any answers? Or should I discuss the weather of my place?
The partially cloud, partially sun.
Okay, our place is cold and it's sunny here, pleasant weather. What about the color of the sky?
Yeah, it's
I will say light blue.
yeah, some reddish also there, some yellowish also there. It's a mixed color.
Okay, and what about the last question? Is India a supporter of Russia?
Not fully, partially support. Not for all
Yeah.
the
So,
reasons.
what were the answers given by us? We never gave any precise answers. Our answers, there was vagueness, imprecision, uncertainty. In other words, not clear is fuzzy. Now, coming to this example, now suppose I am talking about a class of IMSc students taking fuzzy set theory. You have a universe of discourses. So, like you can see here, this is one of the example that is given there. Second, if I ask, who has a driving license? So some will raise their hands, some will not raise their hands. So you can assign a membership 1 or 0 here. Now, when I ask this question, who can drive well, very well? So your reply could be, see, this graded concept is coming in 0.7, 0, 1.0, 0.80, and so on. So now, what do we notice? That fuzzy said the characteristic functions allow various degree of membership for the elements of a given set. See, initially, when we usually spoke about characteristic function, when we spoke about crisp set or classical set, then this characteristic function was replaced with membership functions. So now the two things are there. The difference between the crisp set and fuzzy set. In your crisp set, your valuation set is 0, 1, and in your fuzzy set, your valuation is between 0 and 1. So this is the difference between your crisp and fuzzy set. See, why do I mention the crisp set? Because crisp set, again, it is from here only your fuzzy sets are coming in. So classical sets are called crisp sets. And this we have studied earlier also. If an element belongs to a set, I will assign a membership 1 or I'll assign a membership 0. So I'm talking about the valuation set, something like this. Now, when it comes to fuzzy set, my valuation will be close interval 0, 1. So close interval 0, 1 could mean many more things. As sir has discussed very nicely fuzzy sets, so I hope the definition should be clear. Now, this definition has been taken from the Zimmerman book, where fuzzy set is defined with it is an ordered pair where x is the generic element, mu x is your membership function, and the membership function will be between 0 and 1. So, what can we say about the membership function? See, now fuzzy set means membership function. That means whenever you have to define a fuzzy set, you have to define the membership function. So again, it is based on the user, his requirement, he or she will construct the membership function. So there are infinite number of ways to characterize fuzzy. So infinite ways to define fuzzy membership function. See, somebody will be having some perception. See, now like here, I can see there are around 100 participants. So all 100, if I give to construct a fuzzy set, so the membership function, all different ways will come in here. So basically, membership function embodies all fuzziness for a particular fuzzy set. Its description is essential to fuzzy property or operation. Now coming to the operations, see why I'm mentioning the operations, because in fuzzy optimization, we use the intersection operation. So now we have studied operations in classical sets, union, intersection. Since class 10 onwards we have been studying. Now when I talk about union in fuzzy set, I'm talking about union means, first of all, I have to consider two fuzzy sets defined in the universe of discourse, or universal set capital X. So now when I'm talking about union of fuzzy sets, that means I'm talking about the membership. I have to define the membership mu suffix a union b of x. So it is maximum of the membership function. So this is your union. Intersection, again, I need two fuzzy sets. So intersection, again, I'll be defining the operation of intersection on the membership function. See, whatever operations we are doing it on the membership function. So mu A intersection B of X, we are talking about minimum. So minimum operator is used here. Now similarly, you have the complement. See, I'm not going through any example because my topic is fuzzy optimization and sir has explained all the details very nicely. All the examples and all the things are there, and I think this should be clear now. Now let's come to my topic, that is fuzzy optimization. First of all, I would like to discuss about classical decision theory. See, all of you have studied optimization. So now in classical optimization you have studied. Now when I link it with decision theory, so there are some terms and terminologies, notations which you should know. So in classical decision theory, a decision you can represent with the help of decision alternatives, that is your decision space. Then a set of states of nature, that is your state of space. So a relation assigning each pair of a decision and state a result, and utility function which orders the results accordingly to desirability. See, utility function you'll understand as I move further. See, you are already aware the decision space. When I speak about optimization, when I talk about linear programming problem, so there your decision space is there. Decision space of your constraints. Okay, now those constraints, I do the plotting. Now from those plotting, I try to find out the values of the decision variables. And if my problem is of maximization, I try to find out the maximum of that objective function. And if it is of minimization, then I talk about minimum of the objective function. So this is how a classical decision theory is represented. Now, when deciding under certainty, see, decision making can be under certainty, under risk, under uncertainty. When I talk about decision under certainty, so decision maker knows which state to expect, so chooses decision alternative with highest utility. And when deciding under risk, the decision maker does not know which state to expect because the states are represented in terms of your probability function. So both cases, decision making is difficult. So now our main focus will be decision making under uncertainty. Okay, now decision making under uncertainty. So decision making is non-symmetric here. The decision space is represented by the number of constraints, and utility function orders the decision space via one of the relationships of result to decision alternatives. We have one utility function supplying the order, but have several constraints defining the decision space. Let me give the example of an optimization problem. Optimization, you have a single objective function, so think it as a utility function, and you have several constraints. Okay, so this is how it goes. So now I'm talking about decision making under uncertainty. One beautiful example in Zimmerman's book I would like to give. Now, suppose the example is something like this. See, board of directors want to determine the optimal dividend. Okay. So optimal dividend, that means the objective function is to maximize the dividend. Okay. And the constraints defining the decision space is that the dividend be between 0 and 6%. Now, optimal dividend is 0 and 6% and maximum. So obviously, in this example, your maximum, because you are considering a classical theory. Now, this is the diagram explained here. Optimal decision. So dividend I'm taking on the x-axis. Y-axis is your utility. Your constraints, the straight lines that you're representing is a constraint. Now, suppose if I have to take a decision here. So now here, I'm not talking about decision making under fuzzy environment, a general classical decision under certainty. So obviously the optimal decision will be 6 because I need, accordingly to this, optimal dividend should be maximum, and maximum cannot be more than 6. So this is the case of a classical decision under certainty. Now coming to fuzzy decision. Now, fuzzy environment, this picture of a decision, is revised here. The fuzzy objective function is characterized by its membership function, and so are the constraints. And we want to satisfy the objective function as well as the constraint. So decision in fuzzy environment is defined same way as non-environment as a selection of activities which simultaneously satisfy objective function and constraints. See, if you are recalling in optimization, we are trying to find out the unknowns are the decision variables. So decision variables in fuzzy decision also, we are finding out that in normal non-fuzzy decision also, we are trying to find out the decision variables, and those decision variables will decide the maximum or minimum value of the objective function. That's how we are going. Now, the constraints, they are non-interactive and the logical and corresponds to the intersection. So the decision in fuzzy environment, it can be viewed as the intersection of fuzzy constraint and fuzzy objective function. Now, coming to an example here, you have the objective function defined here with the help of the membership function. Now, suppose I am defining it as x should be substantially larger than 10. So now value is less than equal to 10, you're assigning membership value 0, and greater than 10, this is the membership function defined. See, now look here, this membership, that is 1 plus x minus 10 raised to minus 10, minus 2 raised to minus 1. This, see, this looks easy, but you need to define it. So here, because this is an example taken from the Zimmerman book, so these things have to be constructed here. They look simple, but you need to construct it. So this is x should be substantially larger than 10. I think this example sir has discussed in his talk, so I will not do the explanations. So the constraint here, x should be in the vicinity of 11. Again, there's a membership function for it defined here. Now, what will be your fuzzy decision here? So mu dx, so intersection of your objective function and your constraint. See, here I am talking about fuzzy objective and fuzzy constraints here. Now, how your fuzzy objective and fuzzy constraints are coming here? Because you are defining it with the help of the membership function. So here I am taking the minimum value. So this is how your membership function of the decision is defined here. So this is an example. Now, fuzzy decision, this is how it goes. You have the objective function, your constraint. So intersection will be your decision. So intersection means you're taking minimum value of the objective function here. So this is your fuzzy decision here. Now coming to the previous example, the dividend that had to be paid. So now looking it in the fuzzy angle, so the board of directors is trying to find the optimal dividend to be paid to the shareholders. So financial reason, this dividend ought to be attractive, and for region of wage negotiations, it should be modest. See, now look here, earlier case, when in your classical theory, if we go back to the slide here, classical decision under certainty, here we were just talking about some maximum dividend. So easily we said it is 6%. Now here, now this example that has been revisited, now here some constraints have been put in. They're saying though the dividend has to be attractive, but there should be negotiations, reasons of wage negotiation, it should be modest. So now let me enlarge my screen. Equations could look small here. So now here, yeah, so now the attractive dividend is defined, that is your objective function, and your modest dividend, that is your constraint here. Now we are talking about the fuzzy set decision. So it is characterized by its membership function. So mu dx, minimum of mu naught x. Mu naught x means your objective function. Mu cx means your fuzzy constraint here. So now I am taking the minimum value here. So this is my decision that I am taking. So now decision, as I discussed previously also, it is mu d is nothing but your mu naught x, mu cx. Now fuzzy, if the decision maker wants to have a crisp decision proposal, it seems appropriate to suggest the dividend with the highest degree of membership in the fuzzy set decision, as discussed earlier. Now to maximize the decision, So max min operator can be used here. See, max min operator has to be used in your optimization, and sir has also discussed it. You can still refer to some books, Zimmerman, then your fuzzy mathematical programming. There are several books where your, and research papers also, where your max min operator you can just go through when you're working on this topic. Now this is the optimal dividend as maximizing decision. So it is the, as we can see, earlier it was 6. Now, but when it comes to these two criteria, that the dividend should be attractive also and modest also. Now the value is coming between 3 and 4. So many aspects have to be seen in the decision making. So now I think you should be able to distinguish between your decision making under certainty, again in a fuzzy environment and a non-fuzzy environment, how the results might vary. So this was an example. Now coming to Bellman and Zade, the 1970 paper is very much famous here for the concept of fuzzy decision. So here you have your fuzzy goal G and your fuzzy constraints C. Again, you in a space of alternatives. Now G and C combine to form a decision D. Now which is a fuzzy set resulting from intersection of G and C. So D fuzzy decision is nothing but intersection of your fuzzy goal and fuzzy constraint. And so fuzzy decision is minimum of your fuzzy goal, fuzzy constraint. Now, if you have to generalize the above concept, now suppose you have n goals. Instead of one, you have n. Instead of one constraint, you have several constraints. Now, your fuzzy decision will be intersection of these goals and constraints, and your decision will be again minimum of your constraints and your goals. So this is how it goes. Bellman's and Zade's concept of fuzzy decision here. So see, whenever you're talking about fuzzy optimization, so this, what is fuzzy decision? This is an important paper which you should go through. So Bellman and Zade in 1970 paper, and then Zade's 1965 paper. So these paper, firstly, 19, Zade's 1965 paper, these are easily available. This you have to see Bellman and Zade whether it's there or not. Or in case you need it, you can always contact me. I can provide you this paper. So you should go through these papers, because in fuzzy optimization, these concepts are going to be used over and over again. Now, that coming to fuzzy optimization, so we have to talk about linear programming problems. Now, how does your symbolically a linear programming problem looks like? Maximize Z, you know this symbol Cx. C is nothing but your profit coefficients, or you can say coefficients of the objective function subject to your constraint. So here your A is the matrix of technological coefficient, B is the vector, there are resources available here, X is the unknown, the decision variables, and you have solved the general linear programming problem. So C, A and B are always known. The decision variables are not known. Okay. And LP, you know, it is nothing but efficient allocation of limited resources to the activities with the objective of meeting a desired goal. Goal could be maximizing profit or minimizing cost. So again, it depends upon the problem, whether it is a maximization or a minimization problem here. So this is a general mathematical formulation of an LPP problem. See, whenever you're trying to solve it in fuzzy or whatever approaches, you need a formulation first of all. Formulation is the main, and these approaches you can easily do. Now, where does in our linear programming our fuzzy logic comes in? Now, when I speak about input data C, B, and A, okay, here where your fuzzy impreciseness might be there, there's some incomplete or non-obtainable solution information about C, B, and A. So these are the main important symbols here: C, A, and B. Okay, here only you can do represent it in terms of fuzzy sets, or you can say impreciseness. Now, how can you do this like C, B, and A? Now, suppose when I talk about labor hours, now labor hours, if I want to represent it in terms of fuzzy sets, So I can give the this word around 1220. See, around is a linguistic variable, and as I mentioned previously, it is a mathematical slang or a mathematical, you can say, imprecise statement around 1220. You don't know exactly what it is. So that is how your impreciseness is coming out, about 1550, about 2.3. So these are the ways by which your input data can be represented as fuzzy sets. So around, about, these are nothing but your adjectives, or better would be linguistic variables when I'm talking about fuzzy sets. So this you can represent in terms of membership functions. See, membership, again, either you construct the membership function, and as fuzzy number was explained, so your triangular trapezoidal number are the most easiest representation. And why we prefer your triangular numbers? Because of the ease of operation. The operations are very easy. See, construction of membership function is difficult compared to just using your fuzzy numbers. If you look at the older paper, fuzzy number, the operations are not difficult, especially the triangular if you're using. Okay, now once you have decided, like here, I am considering C, B, and A as fuzzy terms, okay, fuzzy terms or fuzzy sets. Now, we have to construct the membership function, okay, membership functions for when I'm talking about LPP, C, B, and A. Now, membership function indicates a subjective degree of satisfaction within given tolerances. So, as I mentioned, the Bellman and Zadeh concept, that fuzzy environmental goals and constraint have the same nature and can be represented by fuzzy sets. And fuzzy decision, this is what they define in the paper. It is a confluence of the goal and constraints. So this has been explained to you. Okay, now to formulate these fuzzy imprecise numbers, we can use membership functions. Now there are some functional forms of these membership functions. A figure will show the various forms here. Now with these fuzzy imprecise input data, so this is where your fuzzy linear programming comes in. So in this study, the grade of membership indicates a subjective, this I'm repeating it. Now preference, so this is what I can see. Ax less than equal to b, Ax greater than equal to b. So non-decreasing, non-increasing, that's what I can see. Minimum z, maximum z, again non-decreasing, non-increasing. Now suppose if I have to represent Ax is equal to b. See, in your constraints you have these symbols. Either Ax is less than equal to b, greater than equal to b, equality. See, equality you can represent with the help of your triangular and trapezoidal fuzzy number. So these are preference-based membership functions. See, because only these forms will only be there. Either your inequality will be less than equal to, greater than, or equal to, and objective will be, only these terminologies will be there. So this explains the preference-based membership function of fuzzy B, fuzzy A, fuzzy C, or Z. Now coming to the next classification. So Zimmerman was the first to give the fuzzy mathematical programming. He classified into symmetric and non-symmetric. See, fuzzy symmetric means Bellman and Zadeh's 1970 paper, where they talk about your fuzzy decision. And when I talk about non-symmetric model, then I have to determine the fuzzy set decision there. So determination, basically, it is of the crisp maximizing decision by aggregating the objective function after appropriate transformations with the constraints. Then other classifications include somewhere your objective function is crisp and your constraints are fuzzy. Somewhere your objective function is objective. Your objective function is fuzzy and your constraints are precise. Now, somewhere your objective function and constraints both are fuzzy, and then comes your robust programming. Now, again, classification could include flexible programming, mathematical programming. See, with the, you can say, evolution, as more and more people got into the research of fuzzy mathematical programming, they gave their own classifications. So then came the classification of flexible, mathematical with fuzzy parameter. Then came the fuzzy stochastic programming. So fuzzy parameters are so-called fuzzy numbers. They also characterized by possibility distribution. So I'll not go into this. So main is classification of Zimmermann's approach, symmetrical and non-symmetrical. So now again came the mathematical programming problems with fuzzy parameter, two major classification. Either it will be a deterministic objective function or your objective function. So these are the various classifications of your fuzzy mathematical programming. See, here I am talking about fuzzy optimization. I'm just talking using the term linear here, because fuzzy optimization is a vast topic. It could mean linear, non-linear, stochastic, many more things will come in. But mostly I'm dealing with linear, fuzzy, linear mathematical programming. So now this is the basic classification that is coming in. We already know the symbol A, B, C or Z. Okay, so linear we know that what this A, B, C is. Now, when I'm coming to fuzzy programming, the major five problems will be fuzzy B, and fuzzy Z, fuzzy C, fuzzy A, B, and C is fuzzy, A and B fuzzy, A and C fuzzy, or just A fuzzy, B and C fuzzy. So these are the five classifications given. If you have this book of fuzzy mathematical programming by Lei and Wang, so in this is how it is classified. The classification is given. So these some things I will explain. Either one of the classification will be explained, and who has given that classification. Yeah, so this is how it looks like. That looks too much vague, or you can say too much broader. Now this is more simplified. What we are doing here, objective function, what we are doing, to the constraints, what we are doing. So this slide has been beautifully depicted. Now come to the taxonomy of fuzzy linear programming problem. Now, if you want to consider your resources B as fuzzy, then you have the parametric programming, Verdiges, Werner's. Again, all this classification is your fuzzy mathematical programming by Lei and Wang. Now, fuzzy B and Z, Zimmermann approach is very much famous. Fuzzy C, Verdige, parametric programming. And rest are not that famous, but Zimmermann is the most popular approach that we still use. So this is your problem and your approaches. So a taxonomy of fuzzy linear programming. Now, if this you do as fuzzy, so this approaches you can apply, and many more approaches are coming in day by day. So this field also, several researchers are working on it. Some of my papers are there, which you can see in my Google Scholar ID. So there, mostly all the papers are there. Optimization, several papers you will find there where you can see. Okay, now coming to your fuzzy resources as LP in linear programming problem. So fuzziness is applied to your fuzzy linear programming. Now let's consider this formulation. You have an objective function Z, 0.4x1, 0.3x2, subject to your constraints. See, now this LPP you can solve in a software. You can use it in Torah. Torah, if you are using this Taha book, this Torah is there, Torah, or you can use Lindo is also there. Your student free version is also there. So these are the places where you can solve it. The graphical solution, this is how it is done. I hope you are able to see the screen. Now this is the graphical solution. So now if you put, Torah is again not difficult to use. Let me give a demo, or might be I'll just show you what this Torah is actually. This is available with your Taha book, HA Taha, Operation Research and Introduction. If you click here, linear programming, see input screen is there, your title, give whatever you want to, LPP, suppose variables to constraints 2. So here you can label the variables, your objective, maximize, minimize, constraint. So this software is easily available. I hope you are using it. Yeah, are you using Torah?
Yes, madam.
Okay. Okay, just a minute. I'll just share my screen. Okay, so now this was the graphical solution. Simple LPP problem. So Z is 130, X1 is 100, X2 is 300. So this is the solution we obtained. So you can see here graphically the corner points and the various values of Z, though it is not shown here. Here just the optimal solution is shown here. Now suppose from a crisp, I have to go to a fuzzy approach. So how do I go to a fuzzy approach? Let's see. See, available materials may change in some range. So some range, again I'm talking, it is a some range is a fuzzy term. Okay, might be I'm adding additional materials. So that means I need available time may also change. Okay, so this is how fuzzy thinking is coming in here. So this is how we are introducing your fuzzy set theory into the problem. Now, might be I'm not satisfied with the $130 profit. Profit should be substantially large. So now here is my fuzzy thinking here. See now, till now this was a deterministic LPP formulation. Now when I'm moving to a fuzzy LPP, so this is how I am introducing fuzzy thinking in the problem. Okay, next, how do I proceed? Now, fuzzy thinking means these are my membership functions. See, now here you can see 400 is your material, 500 is your labor hours. So this was a limitation. Now, material I want to increase, labor hour I want to increase. So now the membership function of material and labor hours. So now you can see the above table, it shows the membership function of the material and labor hours. They are both non-decreasing. Okay, now the membership function of the material and time, they are provided by the manager. Now he explains that the value of the membership function means the degree of his satisfaction on the constraints, your material and labor hours. Now first of all, G1X, I'm representing the material. Now if it is less than equal to 400, so your constraint is originally this was it. G1X is X1 plus X2 less than equal to 400. Okay, so the constraint is absolutely satisfied here. So now the moment I increase, G1X is greater than equal to 500. So we see what? There is a violation of the constraint. So degree of satisfaction I am putting there 0. Now if I take the value between 400 and 500, so the degree of membership is monotonically, linearly decreasing. Okay. So the manager considers that the only feasible solution should be satisfying the membership function of material, labor, hour, profit at the same time. So the moment, see what is happening there in your LPP, the moment there is violation of your constraint, you are not getting a feasible solution. But when I'm coming to fuzzy linear programming, violation of the constraints is acceptable to a certain extent. Okay, so that is the thing. But in your classical or general LPP, if the once you violate the constraint, you will not get a feasible solution. But in your fuzzy LPP, violation is accepted. So as you can see, for material, the moment I mention 450, I am giving 0.5. Time 550, I am giving 0.5. So that means to certain degree, you are accepting the violation. Now, the feasible alternative with the maximum degree of satisfaction is chosen as the optimal solution of the problem. Now, we see that in fuzzy linear programming, the fuzziness of available resources is characterized by the membership functions over the tolerance range. See, now here, what do you mean by tolerance range? From 400, I am moving to 450, 450 to 500. So, tolerance 50-50, I am increasing. Even for time, it was 450, 450 to 500, 550. So, this is tolerance range. Sometimes it is given, sometimes it is not given. So this comes your fuzzy linear programming. Now the general model of the linear programming problem. Now if your resources, now BIs are fuzzy here. So BI I can take between BI and BI plus PI. PI is a tolerance parameter. As I said, see your BI will be given. Tolerance parameter, again it will depend which approach you are taking. Verdighe, Werner, Zimmermann. So some cases it is given, some it is not given, and some you have to assume. So now we can consider either way you express it, one or two are the same. Your BI you are representing as fuzzy or your inequality. That means that much is your targeted resources. So the general model of this LPP with fuzzy resources, so these are the formulations and PI is your tolerance parameter. Now we assume that that is known here. Okay, now this AX is less than BI is fuzzy will be equivalent to. Now this, when I'm taking as BI as fuzzy, I'll write it as BI plus theta PI. Theta will, theta will be, will belong to a closed interval 0, 1. So this is the formulation here. Now, Werner's approach I am going to discuss. So again, a non-symmetric model. The objective function should be fuzzy along with the total fuzzy resources. That means objective function and constraints both are fuzzy. So Werner's model, what he is discussing, he has defined Z0 and Z1. Z0 mean you'll take the original LPP problem without the tolerance parameter, and Z1 means you'll take the LPP, but in your resources you are adding this tolerance parameter PI. So AXI is less than BI plus PI. This is how you are defining. See, again, this you can solve with the help of Tora or Lindo, whatever softwares that are available in your college. Now, then comes your construction of the membership function. So, construction for the objective function. See, always remember that when you're constructing membership function for the objective function, mu naught is the notation used. Mu naught is the most standard notation, mu naught x for your objective function. Now here I am constructing the objective function z1 1 minus, see this is again 1 when your cx is greater than z1, 0 when your cx is less than z0. So lower and upper range in between, so it is 1 minus z1 minus cx. Cx is nothing but your objective function, and then your difference between your lower and upper. So this is how you construct. So Werner's method, this is the construction of membership function. This is a fixed formula that you will follow. Now, once the construction is done, then comes your formulation. So you are maximizing alpha. Alpha is nothing but your degree of satisfaction. Mu naught x greater than equal to alpha. Mu naught x, if you're recalling, it was the construction of your membership function for the objective function. And mu I x, it was the construction of membership function of your constraints in this case. Okay, mu I x greater than equal to alpha and mu naught x. So this was it. So these are the two constraints. So basically, one thing you must have noticed previously, what happened? You had a maximum objective function here subject to the constraint. This is how you solved. Now here, there are no, your objective function is replaced with maximum for alpha. Now your objective function you have combined with the constraints. That means objective function you have constructed a membership function. So that is coming in the constraint, and mu I x greater than equal to alpha. This is also your constraint that you have done. So this is how the formulation goes. Now this is the graph for the objective function. So now suppose we have this problem. You have an maximize z, 4x1, 5x2, 9x3, 11x4. So these are your constraint G1, G2, G3 with your non-negativity conditions here. Now, when you solve this LPP by maximizing, so Z naught will be nothing but, if you remember this form that I discussed here, maximum of Cx subject to your constraint. So simply you will put the entire formulation in Torah. So Z naught will come out to be 99.29. Okay, next is your with your PIs. See, PIs, I'm going to add, see now your B is 15, 80 and 100. Suppose 15, I want to make 5% increase in B1, B2, B3, 5, 10, 15, 20, whatever you want, you can do that. I have taken 10 probably here. So Z1 is 130 here. So PI is, PIs, I'm putting 5% of 15, 5% of 80, 5% of 100, that increase. So this is how my Z1 here is. So maximize Cx, AXI less than BI plus PI. So now here I get the value as Z1 is 130. Next, I construct the objective function, this formula that is fixed as I mentioned previously. Z1, Z0, these are substituted here. So Z1, Z0, you can clearly see what it is. So this is how it's going. Then comes your constraints here, membership function for the constraints. So mu1, mu2, mu3, again the same as your objective function, except your g1x minus 15, the lower value divided by your difference. So mu1, mu2, mu3. Again, the formulas are fixed there. So this is how membership function of the constraint is going in. Okay, now this was the problem. We formulated the membership function for the objective function, then for the constraint. Now this is how our formulation goes. So formulation, if you are recalling, here your mu naught x was greater than equal to alpha. So 4x1, 5x2, 9x3 plus 11x4 greater than equal to 130 minus 30.71 theta. So difference that I am taking. Similarly, x1, x2, x3 plus x4 less than 15 plus 5 theta. So that means a parameter theta has been introduced here. So this was the formulation. And when you solve, this is what you are getting the solution as x1, x2, x3, x4. This is the value of z. The theta is 0.5. That means the satisfaction level is 0.5, 50%. Not that satisfactory solution. See now these formulations, again this equation that I've got 130 minus 30.71 theta, they are fixed formula for it. And this I've already explained in one of the slides. Here, BI plus theta I. This is how, if your BI is fuzzy, so this is what has been done here. Similarly for your objective function. So this is how it is coming. So 15 plus 5 theta, that means plus 5 theta. Again, let me go back to the slide. Yeah, plus theta into pi. Pi is your tolerance here. So that means tolerances here have been taken as 5, 40 and 30. Now this formulation, when you are solving, so theta is coming out to be 0.5. So this is your Werner's method formulation. Yeah, and I think I've put maximum alpha here. It will be maximum only. So alpha, see there's a relationship between alpha and theta. Theta is 1 minus alpha and alpha is 1 minus theta. So vice versa, this is how it's going. Okay, now suppose linear with, I think the slide is repeated. Now let's come here to your Zimmermann's approach. So this is the most popular approach. Till date it is used in the research papers and general. So Zimmermann's approach, the goal B naught and the tolerance parameter of the are given initially. And see, goal B naught is that means how much should be the targeted value of your goal or your objective. So now this is the Zimmerman's approach formulation, maximize, find x, cx greater than equal to b naught. See again the objective function has been introduced in the constraint and then comes your constraints here. So this is the formulation here, this is the construction of your objective function. Then comes your constraint. See, constraint all over, it will be the same. Variations in the construction of objective function, somewhere or the other, the rules might vary from researcher to researcher. Okay, their own way. But the constraints, everywhere you'll see it is fixed. Now, these are the membership functions for your objective function, increasing, decreasing functions. This is the most simplest form of membership function for the objective function and for the constraints here. So this is your max min operator that they are using here. So again, Bellman-Zadeh max min operator that is used here. This concept I have explained already. Now, yeah, this is the formulation, maximize alpha. If you represent in terms of theta, it will be minimum. So this is Cx greater than B naught minus 1 minus alpha P naught. So this is how your formulation is going here. See, I have highlighted because the objective function is coming in the constraints here. Your constraints are already there. So this is it for my talk. These are the references, the most popular ones. Bellman and Zadeh's 1970 paper, Zimmerman, fuzzy mathematical. See, the approach that is discussed here has been taken from there. Yeah, questions?
Dear participants, it's time to clarify your queries if you have any. Now the session is open for interaction.
Madam,
Yes, sir.
good afternoon, madam.
Good afternoon,
You are
sir.
good afternoon, madam. You are saying from the starting, you are just first slide, whatever you have shared, that you have an interest about in fuzzy and intuitionistic, your research area.
Yes, yes. I'm working on intuitionistic optimization also.
Okay, madam. Now, what is the difference between fuzzy and intuitionistic?
Okay. See, basically, fuzzy has 1 degree of freedom, that is your membership function. Intuitionistic have 2 degree of freedom, membership and non-membership function. See, their membership value is between 0 and 1. There, your membership value and non-membership value is between 0 and 1. So basically, degree of freedom is the difference. One has just the membership, and the other you're playing. You're basically using the membership and non-membership. See, like in your fuzzy, it is only a yes response, but in intuitionistic, yes, no, maybe, hesitancy is also coming in.
Okay. Okay.
And yeah, one more thing is there, like optimization, if you go through fuzzy optimization, you're just constructing the membership function. Intuitionistic, there the construction of non-membership function is there. So little variations is there in the construction of non-membership function. So you can just go through some of my research papers, there you will find the construction.
Okay, madam. Okay, madam. Madam, should I ask another question to you?
Yeah, sure, sir.
Madam, you are saying whatever you have discussed about the linear programming, correct?
Yes, fuzzy linear,
Okay.
yes.
This process is applicable for non-linear also.
Non-linear, so basically the Kuhn-Tucker conditions and all will come in. There will be a variation, sir.
Okay. Okay, okay, madam. Thank you, madam, from my side.
Welcome, sir.
Good afternoon, ma'am.
Good afternoon.
I'm Afrin, ma'am. My question is fuzzy application is used in space? Will it work, ma'am?
See, space, as long as your this optimization problem is there, so you can easily do it. See, everywhere it is there. At Sir has discussed the application, it is used in your air conditioners, then camcorders, in your trains, in your washing machine. So space application, see, like your if then rule base is there. So there it can be used because your washing machine is all rule based, right? Have the whirlpool and all, they're using fuzzy logic there. So space will definitely have some application.
Ma'am, I'm asking in space, ma'am.
Yeah, I said as long as your application should be there. Like, see, your rocket launching and all, angle with which it is launched. So that trajectory and all those things, see, accuracy and I think fuzzy logic should be there for analysis part. You can use that.
Yeah, thank you, ma'am. Now it clarifies.
Yeah, basically rule based. That's what I'll say. If you're in MATLAB, if you're working, see, basically, see, all of us will not be able to work with NASA or ISRO. So we can just do theoretical examples. So because mostly I'm doing theory work more. So I'll just try to relate with theory only. So MATLAB, you have the fuzzy logic toolbox. So fuzzy inference system you can use for your space.
Okay, ma'am. Thank you.
Good afternoon, ma'am.
Good afternoon, Renu.
How to choose an appropriate membership function, shapes, and their parameters in a fuzzy system?
Okay, as I discussed in my presentation, as I have not discussed fuzzy numbers, but your triangular fuzzy numbers, they are the most easiest because of the ease of operations. See, triangular, you can do the addition, multiplication operations very easily, and then the parameters that you're using there. See, now these membership functions also have the various classification. So you can refer to this fuzzy mathematical programming book of Lei and Wang. Okay, so there your it has been classified. See, some places you have the inbuilt membership. See, in my case, like you have to construct the membership. In fuzzy optimization, you need to do the construction of the membership function.
Okay, ma'am. Thank you.
And plus, see, it is all end of the day, it is again user defined. It's up to you. Now, your problem, you will decide like how I want to go about it. Sometimes intuition also. Okay, let me use this triangular. Or sometimes let me do the construction. That's how it goes.
Okay, ma'am. Thank you, ma'am.
Welcome. See, like one thing I will say, like if you want to start on this fuzzy optimization, see now you must be having your PG projects. So that is the best time when you can select and might be from your college, like whoever is interested. So you can always work on this topic.
Is there any more questions, participants? I think they are clear with your presentation, ma'am.
Thank you, ma'am.
Thank you, ma'am. Shall we move to next, ma'am? You want to say something, ma'am?
Yeah, I would first of all like to express my gratitude uh, to the organizing committee, to the college for giving me this opportunity. to showcase my research. I'm really glad and happy to be between the students, faculty members, and I'm glad that I could present something on my area of research. Thank you. Thanks to one and all.
Thank you, madam.
Thank you, sir.
Thank you, ma'am. Actually, we had a great time, ma'am. Thank you, ma'am.
Okay, thank you. Me too.
Thank you, ma'am.
Dear participants, we have dropped the feedback link in the chat box. You can fill it up and get the certificate. Thank you.
No duty is more urgent than that of returning thanks. I deem it pleasure to invite Ms. M. Francisca, Assistant Professor of Maths Department, to deliver the vote of thanks. Welcome you, ma'am.
I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Thankfulness is the beginning of gratitude. Gratitude is the completion of thankfulness. Let me first of all start by giving to the Almighty God for making today's occasion a resounding success. Let us be grateful to the people who make us happy. They are the charming gardeners who make our souls blossoms. First, I thank Reverend Mother C. Noel Rani, FSAG, Secretary, for her blessings and for being our backbone in our entire endeavor and constantly motivating us. Thank you, Mother. Gratitude is a quality similar to electricity. It must be produced and discharged and used up in order to exist at all. I extend my sincere thanks to Reverend Dr. E. Gilita Sumangali, FSAG Principal, the dynamic and flexible in all academic matters. Thank you, sister. A thankful heart is not only the greatest virtue, but the parent of all the other virtues. I would like to express my gratitude to Reverend Sister A. John Diana for her constant help and guidance that radiated a source of energy within us. Thank you, Sister. The value of college education is not the learning of many facts, but the training of the mind to think. I wish to express my gratitude to our resource person, Dr. A. Felix, Assistant Professor Senior, Vellore Institute of Technology, Chennai. His presence today in this webinar has immensely enhanced its importance. We are extremely grateful to you, sir, for your insightful presence. Thank you, sir. As we express my gratitude, we must never forget that the highest appreciation is not to utter words, but to live by them. I would like to express my gratitude to our resource person, Dr. Prabhchar Kaur Bajaj, Assistant Professor, Birla Institute of Technology, Ranch. Thank you, ma'am, for your wonderful presence. Thank you, ma'am.
Thank
No
you.
duty is more urgent than that of returning success. My heartfelt thanks to Ms. J. Megla, convener and head Department of Mathematics, and Ms. M. Jayapriya, organizing president, and all the committee members of Mathematics Department. My sincere thanks to various college, head of the departments, assistant professors, research scholars, and students for their valuable contribution who made this occasion a great one. Be present in all things and thankful for all things. I owe special gratitude to the teaching and non-teaching staffs who have worked to ensure that this occasion becomes a memorable success. Once again, I would like to thank each one of you. I'm very grateful for giving me this opportunity. Be happy, be bright, be you, and have a nice day. Thank you.
On behalf of Konzaha College of Arts and Science for Women and Maths Department, I express my sincere thanks to our resource persons, Dr. A. Felix, VIT, Chennai, and Dr. Prabhatkar Bajaj, Birla Institute of Technology, Mestra, Ranchi, and various college HODs, assistant professors, research scholars, and the students. for supporting us to a successful webinar. Once again, I thank you all. Thank you.
Thank you, participants.
Hello, madam.
Sir?
Hello, madam. Is it possible to share PPT with us, all participants? Is it possible, madam?
Discuss with the resource persons and
If resource persons are available, is it possible, madam and sir? Is it possible to share your PPT with us?
Sir, we shall discuss with the resource persons. I'll share you, sir.
Okay, madam. Okay, madam.
WhatsApp, we will reach you, sir.
Okay.
Thank you. Thank you all.